Hi. So we'll be now starting with mensuration in 3D. I've already taught you mensuration in 2D. The only difference is that in 3D, the surface areas and the total surface area almost remain same, but a new concept of volume comes into picture. Okay. So what actually happens is now we'll be discussing all the shapes that we've done. We've done squares, we've done rectangles, we've done triangles. We'll now be focusing on their 3D counterparts. The 3D of a square is a cube. The 3D of a rectangle is a cuboid. The 3D of a triangle can be a cone when its base is a circle, and further, the 3D of a cone can also be a prism if the base is a triangle or a square, and it can also be a pyramid. It can also be a pyramid. Okay. When I say prism, I actually mean that whatever is at the bottom is also at the top. So naturally, most of the figures that we have are all prisms in nature because they are completely symmetrical. But in terms of pyramid, we start with a bigger base and we end at a point. Okay, we start from a bigger base and we end at a point. So that is a pyramid. Okay, pyramid has a point at top. Pyramid has a point at top, and prism has the same top as it had the bottom. So the bottom and the top for a prism is going to be the same, and for a pyramid the bottom is going to be a shape and the top is going to be a point. A cone is also a type of pyramid which has its base as a circle. Okay, cone is also a sort of a pyramid which has its base as a circle. Now I'll be talking about the few formulas that we have. Trust me, there are very limited formulas which you need to remember. If you can do that, then none of the questions is going to harm you. None of the questions you are going to find difficult. Okay? Everything would be in your control. Let us move forward. Yeah, let us move forward. No, let me first introduce you to all the formulas. Talking about the LSA, which is called the lateral surface area. The lateral surface area is nothing but the area of the four walls. Okay, the area of the four walls of a room. We can consider it to be a room. Firstly, we'll be talking about a cube. In a cube, what happens is that each and every side or each and every face has an equal area, and only one quantity is defined, which is a, which means only one dimension is defined, which is a, and the same dimension is used in length, the same dimension is used in breadth, and the same dimension is used in height. Okay, length, breadth, and height. These would be the three new dimensions. So the lateral surface area of a cube would be equal to 4 times a square. That means a square is the area of one face. When I multiply it by 4, it becomes the area of four faces. We are excluding the top and the bottom. Okay, mind it that we are excluding the top and the bottom. But in terms of total surface area, in terms of total surface area, the top and bottom both are included. Okay, so 6a square would be the total surface area when top and bottom are included. You can say that LSA plus top and bottom is equal to TSA. Then we'll talk about LSA of cuboid, the lateral surface area of cuboid, which is equal to 2 times of the height multiplied by L plus B. This excludes the top and the bottom of a cuboid. Then talking about the total surface area of a cuboid, it would become twice of LB, twice of BH plus twice of HL. Okay, so these four formulas you need to remember. I'll quickly take you through the questions. So the first question itself might be a bouncer. The internal diagonal of a cube is 7 root 3. What is the total surface area? So firstly, there is something which wasn't taught to you in the previous lecture. So what happens here is we have the base of a cube. Okay, this is the base of a cube, and from here, in a 3D manner, a line is reaching the top. a line is reaching at the top face of the room. So I'm basically having a top view of the cube right now. I'm basically having a top view of the cube right now. I'm looking at a cube from the top. So when we start from the bottom diagonal is moving to the top diagonal, or the bottom vertex is going in the opposite direction to the top vertex. So that connection is basically the longest rod which can be inserted in any cube. To achieve that, what we do is I'll help you derive it first. We have A and A two as the two sides of a cube. This is the base. Now this is the height. The height is also same, which is A. Now I need to apply the Pythagoras theorem. I'll apply the Pythagoras theorem and find out this bottom face diagonal. I'll be finding out the bottom face diagonal. The bottom face diagonal is going to be A and A. When A square plus A square both are added, it becomes 2A square. When a root is applied, it becomes root 2A. Now I'll again apply the Pythagoras theorem. Now this is being applied in a manner where I have the base, we have the base diagonal, we have the height. Once I have the base diagonal and I have the height, the value of the base diagonal is root 2A, the value of height is A. I'll quickly apply Pythagoras theorem again, and then I would get the length of the longest rod, which is equal to A square plus twice of A square being equal to 3A square, which is also equal to root 3A, which is also equal to root 3A. So root 3A is basically the value of the longest rod or the internal diagonal of a cube. Now when I'm talking about the internal diagonal, I'm getting the value of root 3A according to the question as 7 root 3. The root 3 and root 3 would get cancelled and I would get the side of the cube as 7. Now it is talking about the total surface area. The total surface area of a cube is 6A square. How and why am I able to memorize, and how and why am I able to recall all the formulas so quickly? Because firstly I've done it multiple times, and secondly I have grabbed the concept. So here is the TSA of the cube which we'll be using in the question. 6A square is the formula that I need to use. A square is nothing but 49. 49 into 6 needs to be given. This would become 300 minus 6, which is equal to 294. So 294 centimeter square is the total surface area of a cuboid. Okay. This longest rod is equal to root 3 times A. The side is equal to A. The side came out to be 7. And that is when I applied the simple formula of TSA. Okay. I applied the simple formula of TSA. Got it? Let's move on. So moving forward, we have another question here. There's a cuboid of size 50 cross 40 cross 30, which is cut into 8 identical parts by using 3 cuts. So this is the first cut here, this is the second cut here, and this is the third cut here. This is the only way in which uh, all the surfaces or all the parts would become identical. Okay, 2 vertically and 1 horizontally. Okay, so I would have what is the total surface area of all the parts? For that, I first need to find out the dimension of one part. Once I have that, then I can simply multiply it by 8 and get my answer. So firstly, I need to find out the dimensions of one part, right? So talking about this is the length that we have. The length is 50. Can we use it somewhere else? Yes, we can. Let's assume this to be 30. Okay, let's assume this to be 30. This entire situation is 30 over here. And when it is cut in 3 equal parts, it becomes 10, 10, and 10. Okay, you can fiddle with it. This is not a problem. The only reason I wasn't using 50 was that because if we divide it by 3, we would get 16.66 or 16 1 by 3. which is a mixed fraction kind of a scenario. 16 2 by 3, which is a mixed fraction kind of a scenario that would have landed us into a more difficult calculation situation. So let's not do that. Let's use 30 over here. Talking about this point, this is the height. Talking about this point, this is the height. The height also got broken down, and let's assume this to be 40. So 20 each. 20 each. Talking about the depth, talking about the depth, because of this, the length is being cut off. Because of this, the height is being cut off. But the depth is going to remain unchanged. Yes or no? Yes, because it's going to be this, this, and this. So the depth is going to remain unchanged. The depth here, we can assume it to be 50. According to the question, this was the only dimension which we hadn't used. So the dimension comes out to be 10 into 20 into 50. Okay, so this is a dimension where I have the L, B, and H. To find out the total surface area, I'll use the formula for a particular cuboid as 2 into LB plus BH plus HL. So what does LB stand for? LB stands for 200, BH stands for 1000, and HL stands for 500. This entire thing is going to be multiplied by 2. So we have 1700 into 2, which is equal to 3400 centimeters square. This is the answer for one part. We need to have the answer for 8 parts. For 8 parts, I will simply multiply 8 with 34. So 8 4s are 32, and 8 3s are 24. 24 plus 3 is 27. So we have 27200 as the total surface area of all the parts together. Okay, this would become the total surface area of all the parts together. Let's move to the next question. The difference between the total surface area and the lateral surface area of a cube of side 12 is this. Is how much? When I talk about LSA, we are only talking about the 4 sides or the 4 walls. When I talk about TSA, we are talking about 6 sides or the top and the bottom included. So the difference between 6 sides and 4 sides is equal to, yeah, is equal to, I'll first, yeah, is equal to 2 sides, is equal to 2 sides. So what is the area of one side? We need to find out the area of one side first. When I'm talking about area of one side first, I need to find out the side itself, the dimensions of the side itself. Let's assume this front side, the front face of the cube is the side we are talking about. So the breadth is going to be 12 and the height is going to be 12. We just need 2 dimensions because we are dealing with only one side. We are not dealing with the whole object right now. So the area of the front face, which I can see in front of me, is 12 into 12. It's equal to 144. This is the area of one side. The difference between the TSA and LSA came out to be 2 sides. So 144 needs to be multiplied by 2. 2 into 144 is equal to 288 centimeters square. So C option is my answer, which is 288 centimeters square. Good enough? Let's move on. Okay. Now we'll be talking about volume of the cube or volume of the cuboid. What happens in case of volume is that the space being occupied by a body is called the volume. Okay, it is the space a 3D solid occupies in the universe. So for that, you may fill it with water, you may fill it with air. Just to find out the capacity, we use the term volume. So volume is calculated by multiplying all the 3 dimensions together: the length, breadth, and the height. In terms of cube, the length, breadth, and height are equal, which is equal to the side of the cube. That is why the volume of a cube is called a cube. Similarly, the volume of a cuboid is called is denoted by L into B into H, which is the length, the breadth, and the height. There can be situations when the cube is hollow and there is some thickness associated with it. In that, if you need to find out the thickness or the material, the volume of the material with which the cube was created or the cuboid was created, in that situation, you'll have to have the complete volume, and subtracting out, you will be subtracting out the volume of the material. Okay, so we are talking about the hollow cuboid volume. If I just need to find out the volume of the material, I would simply subtract the the thickness of the material out of each and every dimension. So L minus 2x is the new length without the material, B minus 2x is the new breadth without the material, and H minus 2x is also the breadth without the material. All right. So, sorry. So, this is another formula which you will have to learn. Also, talking about the diagonal of a cube and that too of a cuboid, I'll tell you, I'll tell you this. So, the diagonal of a cube we've already discussed, we've already derived it as well. So, that is root 3a. But diagonal of a cuboid has the following formula. It has a root. Inside the root, we have L square plus B square plus H square. Okay, you need to memorize this formula as well. So this is pretty much about the volume of the cube and the cuboid. Also, the longest side, or the longest rod which can be inserted in it. Also, the longest diagonal. The longest diagonal and the longest rod is the same thing. Okay, moving on. What is the edge of a cube whose volume is equal to the sum of the volumes of cubes with sides 6, 8, and 10? This is the smallest one. This is 6, this is 8, and this is 10. So I have the volume of the cube as a cube. So for the first one, 6 cube is nothing but 216, 8 cube is 512, and 10 cube is 1000. Now all the volumes are coming together and a new big cube is being formed. So I'll add up all the volumes which I have derived from the baby cubes. The baby cubes are 1, 7, 2, 8. So the total volume which I have, the new volume is equal to 1728. And this 1728 is the volume of the biggest cube which is formed after melting. This is the volume and I need to find out the edge now. So this means A dash cube is equal to 1728. I need to find the value of A dash. That would be the cube root of 1728. The cube root of 1728. So the cube root of 1728, you may memorize this. The cube root of 1728 is 12. So 12 is the side, or 12 is the edge of the cube whose volume is equal to the combination of 6, 8, and 10 cubes. Okay, 6 cube plus 8 cube plus 10 cube is equal to 12 cube. Let's move on. So we have very well managed this question. Now we'll be moving on to the next one. The dimensions of a cuboid are in the ratio 7 is to 5 is to 3. If the total surface area is this, what is the volume? So we have three ratios with us: 7, 5, and 3. Assuming that they are 7x, 5x, and 3x. The TSA is given, the total surface area is given, and the formula of TSA is twice of LB plus BH plus HL. This is equal to 27832. Here, this is L, this is B, this is H. So we have 35x square plus 15x square plus 21 x square. Okay, this being multiplied by 2 is equal to 27832. I'll quickly divide it by 2 and give you 13916, and this entire thing added up would give me 71 x square. I'll directly use a table of 71. 71 ones would go here, and I will be left with 3 less than 42. I would be left with 3 less than 42. That means I would be left with 39. No, 3 less than 71. That would leave me with 68. So 6816. Is it still divisible by 71? Let me see. This is 50 plus. Yes, this is it. This is it. There is no mistake here. I'll use the long division method. It's okay. There can be times when you have to use the longer methods in order to reach the answer. 71 ones is 71. I would be left with 8 here, and I would be left with 6 here. So 6, 8, 1, and no, this is 6, 8, 1 only. 7 nines are 63. Yeah, and yeah, that is where I would come up. 7 nines are 63. I would be left with 2 here and 4 here. 426, 196. So I get 196 here. If the value of x square is 196, the value of x would be 14. Yeah, 14, 13, yeah, 14. So 14 is the value of x, or 14 is basically the value of x, which now would be multiplied by all the dimensions which I have mentioned in terms of ratios. So the length is 14 into 7, the breadth is 5 into 14, the height is 3 into 14. To find out the volume, I need to multiply length, breadth, and height. So the length is 7x, the height is 5x, and the breadth is 5x, and the height is 3x. 7x, 5x, and 3x. So 15 sevens are 105. Yeah, 105. So I have 105 x cube as my answer. I have 105 x cube as my answer. When I multiply 105 with x cube, the value of x cube would be 196 multiplied by 14. When I solve this up, this is going to be my answer. If I try to figure out the solution here, 14 6 are 84, 14 9s are 126, 126, this is going to become 134, and 126, this is 134, and 13 here, 14 ones are, this is going to become 2744. 2744 multiplied by 105. I'll first multiply by 100, so it's going to be 274400. Now I'll multiply it by 5. 5 fours are 20, 5 fours are 20, 5 sevens 35, 37, 5 twos are 10, and 13. So I have 13720. This is 2, this is 11, this is 8, this is 8. So 22,88,120, or 288,120 is my answer. This is the volume. Got it? Only the calculations seemed to be a little daunting, but everything else was in place. Right? Let's move ahead to the next question. A wooden box measuring 10 is to 10 is to 8 with wall thickness 1 centimeter is present. Find the volume of the wood used. Okay, find the volume of the wood used. Firstly, uh, I will be using the formula LBH to find out the real volume of the solid wooden box. I'm considering that it is not hollow in nature. So that would be 10 into 10 into 8, which would be equal to 800 centimeter cube. Now I'll figure out the volume of the cuboid which is on the inside. I'll try to figure out the volume of the cuboid which is inside. So it will also be created with the help of LBH, but the dimensions would have reduced now. The wall thickness is 1. We need to reduce twice of every thickness out of each dimension. So twice of the thickness is 2 here, L minus 2. We'll have B minus 2 and we'll have H minus 2. Once we do that, we get 8 into 8 into 6. 8 into 8 into 6. That means 64 multiplied by 6. 6 4s are 24 and 6 6 are 36. So 384 centimeter cube is the volume of the air passage which is inside. Okay, because it is hollow. I need to find out the volume of the wood used. So 800 was the outer volume, 348 is the inner volume. Whatever is left behind is simply wood. So the question gets completed by solving this. It would be 500, no, 416. So 416 centimeter cube is the volume of the wood used in creation of the wooden box. Clear? Let's move on. The area of the floor of a cubicle room is 64 meters square. The floor which is being talked about is here. Yeah, the floor being talked about is here at the bottom, and the area is 64 meters square. When I say 64 meters square, when I say 64 meters square, that is equal to a square, which is also the side of the bottom, or the measurement of the bottom side. A square is equal to 64. The value of a would come down to 8 meters. So the side of the cube is 8 meters. The length of the longest rod, we already know, root 3 times a, which is equal to 8 root 3 in this case. Okay, so 8 root 3 is my final answer. 8 root 3 is my final answer. Good, let's move on. If the volume of a cube is 729 centimeter cube, then what is the total surface area? If I'm talking about volume of a cube, I would get a cube being equal to 729. A cube being equal to 729. Talking about a, we'll have to find out the cube root of 729. The cube root of 729 is nothing but 9. So a is equal to 9. Now we need to find out the total surface area. The total surface area of a cube is 6 times a square. We have the value of a with us, which is 9. So 9 square is equal to 81. This would be multiplied by 6. So 6 ones are 6, 6 eights are 48. So 486 would be the total surface area of a cube whose volume has already been given as 729. Okay, good enough. Let's move on. What is the side of a cube in which an iron rod of maximum length 10 meters can be placed? That means root 3a is equal to 10 meters. We've already done the formula, that's why I am not repeating it. Okay, so we've already done, that's why I'm not repeating it. Root 3a is equal to 10m. Root 3a is equal to 10m. The value of a would be equal to 10m upon root 3. The value of a would be 10m upon root 3. Now, to solve it, 10 by 3 multiplied by root 3. The value of root 3 is 1.57. 1.57. Yeah. So the value of root 3 is 1.732. This would be multiplied by 3.33. Okay. Or what we could have done is um, we could have multiplied it by 10 and divided the entire situation by 3. So 17.32 divided by 3 would be my answer. 3 5s are 15, 5.7. 5.7 is my answer. So answer is option A. Good enough. Let's move ahead. The length and breadth of a cuboidal box are 25 and 15 centimeter respectively. One of the dimensions is missing. One of the dimensions is missing. If the volume is 1875 centimeter cube, what is the height? We have the volume, it's L into B into H. The volume of the cube is L, B, and H. L into B into H. We have L and B with us. We need to find out H. So this is going to be 25 into 15 into H. This is equal to 1875. Um, I'll be using 25 or no, 625, which is 25 square. I'll use 25 first. 25 sevens are 175 and 175. So I'll have 225 here. 25 nines are 225. Yeah, 25 nines are 225. Let me see it one more time. So yes, this is the question we were talking about. We have the length and breadth of a cuboidal box available with us, and we have the volume as 1875. We need to find out the height. The volume of a cuboid is equal to L into B into H. We have read it already. L into B into H. The volume is 1875. It is equal to 25 into 15 multiplied by H. So 15 ones are 15 ones are again 15 twos are and 15 fives are. 25 ones are 25 fives are. The value of height comes out as 5 centimeters, which we have solved using the standard formula of volume of cuboid. Let's move ahead. A cuboidal water tank is 12 meters long, 9 meters wide, and 7.5 meters deep. How many liters of water can it hold? So first let me find out the value of it, then we can move it to absolute terms. Okay, first let me find out the value of it, then we can move it to absolute terms. So the volume that we are talking about is equal to 12 multiplied by 9 multiplied by 7.5 multiplied by 7.5. So 12 nines are 108 and then 7.5. I don't think this is a comfortable calculation. Let me make it a little more comfortable. 12 into 9 into 75 upon 10. This is 5 twos are, this is 5 15s are, this is 2 6 are. Now this is comfortable. 15 6 are 90 and 19 nines are 810. So I can clearly say that 810 is my answer. This 810 is in the terms of meters cube. Is in the terms of meters cube. 1 meter cube area can have can contain 1000 liters of water. Then how much would 810 meter cube volume contain? It would contain 810 and another 3 zeros would come. So my answer is 8,10,000, or simply 81,881 4 times 0. That is the liters of water this cuboidal water tank can hold. Right? Let's move to the next question. The next question is particularly on diagonals and one or two more special formulas. We have already talked about the diagonal of cubes. We have already talked about diagonals of cuboid. There can be a situation where you are given just the face areas. Where you are given just the face areas. So in these face areas, what would happen is you put all the face areas together. There are three faces, three kinds of faces. So you put all the three kinds of faces together, put them in an under root side, put them in an under root sign, and you are good to go. So if you need to find out the volume of a cuboid using just the face areas, do this. Do this. Yeah. Also, if we have such a formula where L plus B plus H whole square and we open it up, we tend to find that D square plus TSA. D square means the diagonal square and the total surface area. When it is added, it makes up for L plus B plus H square. L plus B plus H whole square. Okay. So this is a very different thing which you might see over here. There is not much utility for it, but if at all it comes, you will not be in any kind of a trouble. Okay. Moving on. The area of the floor of a cuboidal room is 64 meters square. What is the length of the longest rod? We are in a cubical room, so the value is root 2a. No, it's the area of the floor. So area of the floor is equal to a square, which is equal to 64. From here we get the value of a as 8. So we now need to find out the longest rod's length. The longest rod's length is already equal to root 3 times a. So 8 root 3 would be my answer. Are you able to understand how easy mensuration 2D and 3D can get if you are just able to recall the right concepts at the right time? There's not a lot of calculation to do. You are just supposed to plug and play. Okay? Moving ahead, the sum of the length, breadth, and height of a cuboid is 28 centimeters. Its total surface area is 588 centimeters square. What is the length of its diagonal? The formula which I talked about over here, being an obscure formula, seems to have come in the examination once or twice. So from here, we can see that length of all the dimensions of a cuboid are given. From there, I can say that length of or the sum of all the sides of a cube when squared up give me the diagonal square plus the total surface area. So here I'll write it one more time. L plus B plus H whole square is equal to diagonal square plus TSA. Okay. We need to find out the value of the diagonal from here. We have the sum available with us, which is nothing but 28 square. This is equal to the diagonal square plus 588. To quickly find out the square of 28, the square of 8 is 64, the square of 2 is 4, 2 8s are 16, 16 2s are 32. I would add 320 in this. This would become 784. So from 784, 588 needs to be subtracted. From here, I would get a 6 in the end. This would become a 9 and this would become a 1. So the value of d square or diagonal square is equal to 196. The root of 196 is 14. So the length of the diagonal in this situation is 14. Right? The length of the diagonal in this situation is equal to 14. Let's move ahead. The areas of three adjacent faces of a cuboid are 32, 24, and 48 centimeters square each. What is the volume? What is the volume? In such a situation, we've already talked about it, that you need to put all the faces together in multiplication and put them in a root. How would that affect me? LB multiplied by BH multiplied by HL. This is something which has been given to us. When you put a root on it, the couples get separated and the output of this comes out to be LBH. The output of this comes out to be LBH. The output the output of this comes out to be LBH. Now I'll do that. I'll multiply 32 with 24 with 48 and put all of them in a root. Let me take out things which seem to be common. 24 would definitely come out as common because 24 into 2 is 48. That 2 will get multiplied with 32 and would give me a 64, and root of 64 is 8. So 24 into 8 would be my answer, where the final answer would be 192 centimeter cube. Okay, 192 centimeter cube is my final answer. Good enough? Let's move ahead. Let's move ahead to the next question. Yeah. So, what is the length of the longest diagonal of the cuboid? What is the length of the longest diagonal of the cuboid? Just a second. Another second, please. Yeah. So, the length of the longest diagonal of a cuboid with dimensions this, this, and this. We've already discussed it. We have the root here, root L square plus B square plus H square. So L square is 169, B square is 121, and H square is 400. All of this would again go into the root. So this comes out as 521. No, this comes out as 600, 680, 90. This comes out as root 690. Yeah, this comes out as root 690. What is it closest to? The square of 26 is 676. Nothing comes closer to 690 more than 676. So I think this is the closest, which is my answer, 26.27. Okay, root 690 is 26.27. You don't have to be like a hardcore math guy to understand that the root of 690 would definitely fall very close to 69 to would fall very close to 26. So 26.27 is my answer. Moving ahead. Now talking about a few stacking and melting logics. What happens when we melt a smaller cube or multiple small cubes into a bigger cube, or a bigger cube into multiple smaller cubes? What actually happens is that the volume always stays conserved. The volume doesn't change. Okay, whatever is coming in is what will go out. So again, the same formulas. Volume of a cube is a cube, volume of a cuboid is lbh, TSA of a cuboid is 2 into lb plus bh plus hl, and whenever n cubes are stacked, then the length changes by n times. Also, volume 1 is always equal to volume 2. That means the law of conservation of volume. Okay, we've just derived this new term, the law of conservation of volume. Here, the question says that 6 cubes of each of side 2 centimeters are joined end to end. What is the total surface area of the resulting cuboid? Okay, these are 6 cubes which are joined end to end. So here it would be 2 would be the height, 2 would remain the depth, but the length would change. The length would change to 6 times of 2. So the length would change to 12, the breadth would remain the same, and the height would also remain the same. Talking about the total surface area of a cuboid, the answer is 2 into LB plus BH plus HL. We've already discussed it. I'm still writing it so that you are able to recall it in the exam. LB is 24, BH is 4, HL is again 24. This thing is going to be multiplied by 2. 24 plus 24 is 48, 48 plus 4 is 52, 52 into 2 is 104 centimeter square. 104 centimeter square. So this was what I was looking for. Got it? Let's move ahead. A cuboid of sides 8, 27 and 64 is melted to form a new cube. What is the ratio of the total surface area of the cuboid and the cube? Let me first quickly find out the total surface area of each cube or of each cuboid which is given. Cuboid TSA, the first one, the second one, and the third one. The total surface area of no, these are not three cuboids. This is only one cuboid. Okay, so the TSA would be twice of LB plus BH plus HL. So twice of 8 sevens are 56, 8 twos are 16. This is 216 plus 27 into 64. I'll do this later. Plus 8 into 64. This is 512. This is 512. I need to find out the ratio. What is the ratio of the total surface area of the cuboid to the cube? First of all, let me think of melting it as well. That would be a better idea. 8 into 27 into 6 into 64 would be the total volume. If I root it down, or if I cube root it down, that would give me the side of the cube. That would give me the side of the cube. Here, I'll need to find out 3 pairs of each and everything which would come out. So 2 cube is equal to 8, 3 cube is equal to 7, and 4 cube is equal to 64. So 2 into 3 into 4 is my answer, which is 6 fours are 24. 24 is the side of the cube. Now I need to find out the total surface area of the cube. The total surface area of the cube is equal to 24 into 24 into 6, because the answer is 6a square. So 24 into 24 into 6, this is the TSA of the cube. Now going back to the cuboid. In the cuboid, I found out the TSA like this. I think we should solve it up now. This would give me a 28. This would be 728 plus 27 into 64. 27 into 64, can I do a 9 and a 3 later? 9 fours are 36, 9 6 are 54. This is 576 multiplied by a 3 again. 3 6 are 18, 3 sevens are 21, 3 5s are 15, 3 5s are 15 and 17. So we have 1728 plus 728. 1728 plus 728. This would give me a 56 here and a 24 here. So 2456 is 224 into 24 into 6. This is my answer. I need to find out the ratios now. Would it get this is 10, this is 17. No, it is not a multiple of 3. What about 8? 8 5 is a 40, 8 7 is a 56. Yes. 8 3 is a 54. 8 2 is a 16. No, 8 3 is a 24. 307. 307. So we have 18 fours are 72. 18 twos are 36. 36 plus 7 would be 43. So 432 is to 307 is my answer. Okay, this is the answer that I was looking for. Good enough. Let's move on. A cuboid of this size is cut into small cubes of edge 4 centimeter, how many such cubes can be formed? So we have 20 multiplied by 16 multiplied by 8, 20 multiplied by 16 multiplied by 8, and the cube of small edges are 4 into 4 into 4. Following the same law of conservation of volume, that the volume is going to remain the same, this would help me with the number of small cubes that are going to be produced. We have 4 for the 16, this is gone, this is 4 5 is a 20, this is 5 8 is a 40. So the answer is 40 cubes. You might feel that this is a shortcut. I will do it in a long way. I am finding out the volume of the first solid which we are talking about, which is a cuboid, which is 20 into 16 into 8. Now I'll have to find out the volume of the second thing that we're talking about, which is a cube of side 4. So this is 4 into 4 into 4. If this 4 cube is equal to 64, then how many cubes of the volume 64 would make up for the volume of a cuboid with the dimensions 20 into 16 into 8? So the value of n comes out to be 40 cubes. And this is what we were looking for. Okay, 40 cubes is the answer. Let's move ahead. I think we have done this question here. 432 is to 307. 307 is to 216. 432. Was there a gap that was created here? Yeah, this is it. Maybe we've already solved it. Okay, we have already solved it. Let me just go back and find out if there is any correction that needs to be done here. All right, so we have already solved this question in the past. Like 2 slides back, we've just solved the question, so won't be doing it again. Moving to the next problem. Now we are talking about 4 walls and the floor. The LSA, the LSA, or the formula in which LSA needs to be found out for cuboid. That formula is 2h in the bracket L plus B, 2h multiplied by L plus B. If you also include the area of the floor in it, you will have to add a term which is L into B in this situation. Okay, that's it. Also, there is another way out. There is an alternate way. The alternate way says that the required area is equal to TSA, the total surface area, minus LB, minus the roof. Okay, minus the roof. The roof would have the same dimensions as the floor. Okay, because it's a symmetrical figure. That is why the roof will have the same dimensions as the floor. Okay, moving ahead. A swimming pool is this long, this wide, and this deep. What is the cost of cementing its floor and 4 walls at 25 rupees per meter square? So just see what we are doing. A swimming pool is 40 meters long, length 40, breadth 30, and height 2.2. I'll use the formula 2h in the bracket L plus B plus LB. This makes for the floor and this makes for the four walls. We have L, we have B, we have H. The 2 into H comes out to be 4.4. The L plus B comes out to be 70, and the L into B comes out to be 1200. Okay, 7 fours are 28. This becomes 308. Okay, this becomes 308. 308 plus 1200 makes for 1508. So 1508 centimeters square is the area which we are looking at. 1508 has to be multiplied by 25 to find out the total cost. 1508 has to be multiplied by 25 to find out the total cost. If I multiply it by 4 and I also divide it by 4, the 25 into 4 would convert itself into 100. That is easier for me. So 4 3s are 12, 4 7s are 28, 4 7s are 28, 37700 is the answer that I am looking for. Okay, this is the answer that I am looking for. Let's move ahead. The sum of length and breadth of a cuboid is 16. If the height is 1/4 of that sum, find the lateral surface area. I have L plus B with me. L plus B is 16. The height is 1/4 of the sum. That means it is 16 by 4, which is equal to 4. Find the LSA. The LSA stands for 2H multiplied by L plus B. 2H multiplied by L plus B. So 2 into 4 becomes 8 and L plus B is still there, which would be multiplied by 16. 16 8s are 128, which is my final answer. Okay, 16 8s are 128, which is my final answer. Let's move ahead. Now we are talking about cylinders. Okay, now we are talking about cylinders. Cylinders is basically an integration of multiple circles in a plane. It is nothing but the integration of multiple circles in a plane which are stacked one over the other. Why do I use the word integration? Because once the circles are continuously stacked together, instead of circles having zero height, which is a 2D concept, it converts itself into a 3D concept by having a height component as well. So everything remains the same in each and every calculation, be it that of circumference or the curved surface area or the total surface area, or also that of a volume of a circle. Volume of a circle is not possible, but volume of multiple circles stacked together is possible because a new dimension of height comes into the picture. So there's nothing very difficult, nothing very different. I'll show you that we are following almost the same thing. The curved surface area of a solid cylinder is the circumference of the base multiplied by the height. The total surface area cylinder of a solid cylinder is nothing but 2 pi RH, which is the curved surface area, plus pi r square, and that too two times. Why? Because there is one head which is at the top, one circle at the top, and one circle at the bottom. One circle at the top and one circle at the bottom. So this is how the situation comes up, right? This is how the situation comes up. Talking about curved surface area of a hollow cylinder, it is 2 pi h in the bracket r, capital R plus small r. Okay, 2 pi. So it's basically 2 pi rh of the outside, which is the capital R, and 2 pi rh of the inside, which is small r. Okay, I'll show you with the help of a bottle. Let's assume this has heavy thickness. Right now you can see this bottle doesn't have a lot of thickness. It has very few, maybe even less than a millimeter thickness. Let's assume it is a thick bottle. The outside of it, the outside of it would have a radius which is bigger than that of the inside radius. The outside radius would be bigger than that of the inside radius. That is why whenever I'm trying to figure out the curved surface area, there are two curved surfaces. One is on the outside and the other is on the inside. So one curved surface area plus the internal curved surface area. That is how we reach the curved surface area of a hollow cylinder. If we talk about the total surface area, at that time we will have to include the cap as well as the bottom. Okay, I hope you're able to visualize what I'm talking about. Easy, right? So you may remember the formulas, you may not remember the formulas. We will definitely come back to see how well we did. Okay, so let's move ahead. Now, the sum of the radius and the height of a cylinder is 55. If the height is 15 more than the radius, the height is 15 more than the radius, find the curved surface area. We have the radius plus 15, which is equal to height. We also have h plus r being equal to 55. We can use this value of h above. This becomes 15 plus 2 times of r is equal to 55. So 2 times of r becomes 40, and the value of r I get is equal to 20. If r is equal to 20, the height becomes 35. The height becomes 35 if the height is 15 more than the radius. Now I will simply apply the formula of the curved surface area of a rectangle. Sorry, curved surface area of a cylinder. The curved surface area, I have the radius. Radius is 20. I have the height. I have the height now. The height is 35. So when I have 20 and 35 in my kitty, I simply apply 2 pi RH formula. 2 into 22 over 7 into h into h is 35 into 20, which is the radius. So this becomes 5, this becomes 100. My answer comes out as 4400 centimeters square. It becomes 4400 centimeters square. So this was the answer that I was looking for. Good enough? Let's move on. So yes, we are on the next question. Here it says that a rectangular sheet of 44 centimeters multiplied by 12 centimeters is rolled into a cylinder along its length. So this is the length and this is the breadth. It is rolled along its length. That is why the 44 centimeter of length which it has gets converted to a circumference of the new cylinder. So 44 is equal to 2 into 22 by 7 into r. With the help of that, we find out the radius of the cylinder. We find out the radius of the cylinder through that. This gets cancelled and we get the value of r is equal to 7 centimeters. We need to find out the curved surface area. For that particular thing, we will have to mm, we will have to find out the height. We already have the height with us. The height is equal to 12 centimeter. Again, using the same formula, 2 into 22 by, no, this is 2 is not required. 2 pi rh, yeah, 2 pi rh. 2 into 22 by 7 into r into h. This gets cancelled off. This is 44, 12 fours are 48. We have an extra 2. So 528 centimeter square is the curved surface area of the cylinder. Okay, 528 centimeter square is the curved surface area of the cylinder. Got it? Let's move ahead. An iron pipe has an external diameter of 20 centimeters. That means from here till the outside, it has a radius of 10. Okay, because diameter upon 2 would be equal to the radius, and the wall thickness is 1 centimeter. The thickness that we are talking about here, this thickness which is lying in the yellow portion, is equal to 1 centimeter. This means that the internal radius is 9 centimeters. The internal radius is 9 centimeters. Its length is 12. Find the total surface area. In this particular scene, we would have a set of 3 surface areas which we need to find out. First of all, being the curved surface area of the outer side, second one being the curved surface area of the inner side, and the third one being the curved surface area of the rings, the curved surface area of the rings, right? How would that be computed? Let's first talk about the outer side. The outer side has the external diameter as 20, so divide by 2, it will give us the radius 2 pi rh. 2 into 22 by 7, 2 pi r is equal to 10, and the height has been given as 12. Similarly, the CSA inner would come as 2 into 22 by 7 into 9, which is the new radius of the inside, multiplied by 12, because the height remains the same. Now, talking about the rings. The rings are nothing but two concentric circles. The one which is inside has a radius of 9, and the one that is outside has a radius of 10. So, the formula which we'll be using over here is 2, because of 2 rings multiplied by pi capital R square minus small r square. Capital R square is 100 minus small r square is 81. So 100 minus 81. So what I actually get here is 2 pi multiplied by 12. 2 pi multiplied by 12 with 19 being here in the bracket. This is me adding the curved surface area of the outer and the inner side. Now talking about the rings, we again have 2 pi being multiplied by 19. Let me add everything together. I get 2 pi multiplied by 19 multiplied by 12 plus 1. That would give me 13. So the total surface area in this situation comes out to be 19 threes are 57, 19 ones are 19, and this is 24. 247 multiplied by 2 into pi. Um, this would give me a 94. Yeah, this would give me a 494 here. 494 pi is my final answer. Okay, 494 pi is my final answer. I hope you are able to understand the steps that I'm talking about. The first one being the CSA outer, the second one being the CSA inner, and the third one being simple areas of the rings. Okay, simple areas of the rings. Good enough? Let's go ahead. A hollow pipe of diameter 20 and thickness 1 has this. What is its surface area? Okay, so the only difference between the previous question and this question is that in the previous question we had to consider the rings. Because it was talking about the total surface area. Here it is talking only about the surface area, and I can consider this to be the curved surface area. So I'll just do CSA outer and CSA inner. This CSA outer and CSA inner would give me my final output. The same story, 10 is the external radius, same story, 9 is the internal radius. So 2 pi r is 9 in one case, 2 pi r is 10 in the other case, with the height being 12 in both cases. I'll add both of them up. So I will get 24 pi common, and the 9 and 10 would get added up to 19. So I would get 19 into 4, which is 76. 19 to the 38, 45, 456 pi would be my answer. Now, I won't be taking pi as 22 by 7 because it hasn't mentioned that. Furthermore, it hasn't talked about it hasn't talked about the decimals in any of the places. So 456 multiplied by 3.14. I'll simply first multiply with the 3.14 so as to get a ballpark figure, and this will help me in the exam to reduce time. This will help me in the exam to reduce the time. Okay. So I'll quickly multiply it by 3. 3 6 are 18, 3 5s 15, and this is 16, 3 4s are 12, 12 and 13. So 1368, if I'm not wrong. Yeah. So do we have anything which is closer to that? Not right now. We'll see. I think they are also considering in the surface area, they are also considering the rings. They're also considering the rings. So there's a very small factor that we are missing out in the question, and the factor is that of 0.14. When 0.14 is multiplied by 456, the actual number is pretty big. The reason being that 14 forza is 56 and another zero point 0.5 is involved, so another 7 gets added, which adds 63 into the equation. So 1368 plus 63, I would get 13, 1431. This 1431 is very close to 1441, and that is what I am looking for. Okay, that is what I am looking for. So 1441.48 is my final answer. Let's move ahead. We're talking about volume of cylinder. The volume of cylinder has a simple formula. The area of the square which is at the bottom, sorry, the area of the circle which is at the bottom, and multiplied by the height. Multiplied by the height. So that would give me the area of the cylinder. That would give me the area of the cylinder. When we are talking about the volume, sorry, that will give me the volume of the cylinder. When we are talking about the volume of a hollow cylinder, whenever we are talking about volume of a hollow cylinder, we have to take into consideration the outer radius and the inner radius. The outer radius would create a bigger volume, the inner radius would create a smaller volume. The bigger volume minus the smaller volume would give me the volume of the material with which the cylinder is has been created. Okay, so the weight is equal to density into volume. This is another formula which you must remember. And 1 meter cube volume is equal to 10 lakh centimeter cube of volume. 1 meter cube of volume is equal to 10 lakh centimeter cube of volume. Do remember this. Okay, let's move on. The radius of a cylinder is 5 times its height. If the height is 3.5 centimeters, find the volume. The radius is equal to 5 times the height. The height has been given as 3.5 centimeters, right? So the height is 3.5 multiplied by 5. This is 15 point, this is not 15, this is 17.5. This becomes the radius. We already have a height as 3.5 available with us, so the volume comes out to be pi r square h. Pi is 22 by 7 multiplied by 17.5 multiplied by 17.5 multiplied by 3.5. I would get 1,000 in the denominator. 7 ones are 7, 7 twos are 14, 7 fives are 35. Sorry, yeah, 7 fives are 35. This is 25 ones are, this is 25 40s are, this is 5 sevens are, this is 5 eights are, this is 2 fours are, this is 2 11s are. Okay, so I have 175 multiplied by 11 multiplied by 7. So I'll quickly first multiply it by 5 by 11. So this is 5, this is 12, this is 9, and this is 1. Yeah, 11 fives are 55, 11 sevens are 77, 82, 11 ones are 11, 19. So 1925 multiplied by 7 whole upon 4. 7 fives are 35, 7 twos are 14, 14 is 17, 7 nines are 63. This is 64. And 7 ones are 7 plus 6. 7 ones are 7 plus 6 is 13475. Whole divided by 4. Just one last step left. 4 threes are 12. 4 threes are 12 again. 4 6 are 24. And 4 yeah, 4 6 are 24. And 35. 48.75. So 3368.75 is the final volume. Okay, this might seem like a little difficult and a typical question of mensuration, but this is what would be expected out of you in the examination. Okay, you just have to improve your calculations and move just a little bit faster, and you'll be able to solve the question easily. Okay, let's move ahead. The length of the pipe is given, its external and internal radii are also given. If 1 centimeter cube of the volume of the metal weighs 7.5 grams, find the total weight. Here, if I find out the volume of the hollow pipe, if I find out the volume of the hollow pipe, I will be able to clear things up. How would I do that? The volume of the hollow pipe would be equal to pi h multiplied by capital R square minus small r square. We have already done it here. We have already done it here in this part, right? Just let me reconfirm. Yes, cap pi h multiplied by capital R square minus small r square. This is the volume of the hollow pipe. The best part is the height that is given to us is divisible by 7. So we'll be seeing easier calculations from the beginning itself. 22 by 7 multiplied by 756 upon 100 multiplied by capital R square minus small r square. Capital R square minus small r square can be converted to capital R plus small r multiplied by capital R minus small r. So this is nothing but a square minus b square being equal to a plus b into a minus b. So 2.5 plus half plus 1.5 is equal to 4, and 2.5 minus 1.5 is equal to 1. So here it is 7 ones are 7, 108. 108 multiplied by 22, it is 176. 176, and this is 2376. This is 2376 multiplied by 4 and divided by 100. 4 6 are 24, 4 7s are 28, 4 3s are 12, 4 2s are 8, and 9. 9504 or 95.04 is the volume at first. This 95.04 has to be multiplied by 7.5 grams. For this multiplication, and for the ease of taking things forward more quickly, I will split it 7.5 into 2.5 into 3, and for better convenience I'll multiply it by 4 and divide it by 4 so as to create a 10 out of it. 7504 whole upon 100. Okay, now let's start cutting things. This would give me a 10, and this would eat up a 0 for me. 3 4s are 12, 3 5s are 15, 3 7s are 21, 2 2 1 5. Yeah, and whole divided by 4 is still required. Yes, it is. 4 5s are 20, 4 6 are 24, 4 2s are 8, 4 8s are 32, and 568, sorry, 562.8, or round about to 562 grams is the total weight, or 563 grams is the total weight of the metal pipe. Total weight of the metal pipe. Good enough. Let's move ahead. Now, 60 discs of diameter 21 centimeters and thickness 1 by 3 centimeter are stacked to form a cylinder. If the discs are 60 in number and each of them are 1 by 3 centimeter in thickness, then the total height of the cylinder would come out as 20 centimeters. If the diameter is 21, if the diameter is 21, so 21 upon 2 would be the radius. Further, I'll mark the height here as 20 centimeter. Using the simple formulas about volumes and that too in meters cube, that is the catch. That is the only catch here. So I will use the formula now. So pi r square h is the formula for volume. 22 by 7, 21 by 2 into 21 by 2 into h is 20. This is 4 and this becomes 5. This becomes 3. 21 into 22. 21 into 22 becomes 42 and another 42. This is becomes 462. This becomes 462. 462 multiplied by 15 is where I'll find my answer. And 6930. 6930 is the from the question. We are like continuing in the same question. The only difference that we are going to talk about here is that 6930 was something that we achieved. 6930 was something that we achieved. Let's consider a case where all the options were 6.930 or something, and just the units were different, or the power of 10 or the exponent of 10 was different. Had this been the case, it would have been difficult for you to understand what is actually going on. My answer here is 6930 centimeters cube. So if I wish to convert centimeters cube to meters cube, we are going from a smaller unit to a bigger unit. That would entail pulling in a division sign. Okay. If 1 meter is equal to 100 centimeters, 1 centimeter cube or 1 meter cube is going to be 100, 100 and 100 three times. So that means 10 raised to the power 6 would come in the base. 10 raised to the power 6 would come in the base. Now, both the powers, like I'll try to justify what I'm talking about. I'm talking about there being 6930 and there being 1, 2, 3, 4, 5, 6 zeros here. If the answer isn't 6.93 or two exponents here, but we have a zero which would get cancelled away. So two exponents have been used with the help of, two decimals have been used with the help of two zeros. Now we have three zeros left, which would in turn come into 10 raised to the power minus 3 meter cube. Okay, 6.93 into 10 raised to the power minus 3 meter cube. I hope you're able to understand this, right? 6.93, achieving 6930 was not difficult. But had there been a question where they would have changed all the powers of 10, that would have become a little difficult, very little difficult. Okay, so I'll be moving on to the next question. Yeah. So now we'll be talking about thickness as well. We'll be talking about thickness as well. We'll have this curved surface area, which is 2 pi RH. We have already talked about it. The total surface area is 2 pi r in the bracket h plus r. The volume is pi r square h. This is already what we've been doing. We'll talk about the hollowness or the volume of a hollow cylinder. What happens in the case of a hollow cylinder is that there are two cylinders, one in the other. Okay, there are two cylinders, one in the other, and there is this material which is filled in. Okay, or there is a material which binds both of them together. One hollow cylinder here and another big cylinder there. So one cylinder doesn't have anything in it and the other cylinder has another cylinder in it. So in this sort of a situation, if you wish to find out the volume of that hollow cylinder, so this would be the volume, pi h multiplied by capital R square minus small r square. Capital R is the outer radius, small r is the inner radius. Okay, and the thickness of that hollow cylinder is going to be r minus h. Okay, the thickness is going to be the outer radius minus the inner radius. When you leave that, so this portion gets minused away or this portion gets subtracted away. This portion is left, which is the actual thickness of it. Okay, I'll be moving forward. The numerical value of twice the curved surface area of a right circular cylinder equals its volume. What is the radius? In such questions, you are supposed to quickly just write down the formula. The formula what we have over here is 2 pi RH, which is the curved surface area. 2 pi RH, this is the curved surface area. This entire thing is multiplied with a twice, because the numerical value of twice the curved surface area is equal to the volume. Okay, the volume comes up with pi r square h. The pi and the pi get cancelled. 1 r cancels away the power, h cancels away the other h, and the value of r comes out to be 4. So the numerical value of the radius is nothing but 4 units. Okay, the numerical value of r is nothing but 4 units. Got it? Let's move on. A hollow pipe 1.4 meter long, which would ultimately become its height. The external radius is 9 centimeters and the volume is this. So we need to find its thickness. We have the volume available. We know the formula of a volume of a cylinder which is hollow in nature as pi h multiplied by capital R square minus small r square. To find out its thickness, we would need to know the value of capital R minus small r. Here we already have the external radius. That means we have the value of capital R. By putting in the values, we will achieve the value of small r, and capital R minus small r is something which we need to find out. Okay, so this is equal to question mark here. So the volume has already been given as 7480. I'll quickly check if all the units are working out pretty well. The answer is no. The height has been given as 1.4 meters and the radius is in centimeters. Also, the volume is in centimeters cube. So I will prefer to pull everything into centimeters. If 1 meter is equal to 100 centimeters, 1.4 meters would come down to as 140 centimeters. This is the height. Using pi as 22 by 7, using capital R as the radius, which is 9 square or simply 81 minus r square, is that thing which we need to find out. So this would give me a 20. This would give me a 11 2s are 22. This would give me an 11 6 are 66. 11 8s are 88 and 0. Okay. So another 4 is here. 4 1s are 4. 4 7s are 28. The 0 would get cancelled here as well. Okay. So I have 81 minus r square being equal to 17. Okay, so the value of r square is 17 would be subtracted away, which would give me a 64 here, if I'm not wrong. Yes, it would give me a 71. 71 minus 7 is 64. So the value of small r square or the inner radius of the hollow cylinder is going to be 8. Okay, so the value is 8. Once the value of small r is 8, then the value of capital R, the value of capital R has already been given as 9 centimeters. Okay, we have the external radius, we have the internal radius. The value of the external radius minus the internal radius is going to be my answer. So 9 minus 8 is going to be 1 centimeters, and this is going to be my answer. Okay, I hope that's good. I hope that's enough. Let's move ahead. A hollow cylinder has an external radius of 6.75 centimeters. Internal radius is 5.25. We have the height. It is melted to form a solid cylinder of half the height. Okay, the melted cylinder of half the height is supposed to come in. So find the radius of the solid cylinder. We need to find the radius of the solid cylinder. So here the volume 1 is going to be volume 2. As simple as that. We are considering the first one to be a hollow cylinder, and we are considering the second one to be a solid cylinder. Okay, we have a hollow cylinder and a solid cylinder. So in the hollow cylinder, I'll use the same formula of pi h multiplied by capital R square minus small r square, which is going to be equal to pi r square h, right? The heights are going to be different. It has been said that the solid cylinder is going to have a height which is half of the other one. So I'll quickly put down the values. I have pi here. I'm not writing it 22 by 7 because ultimately it's going to get cancelled out. The height of this hollow one is going to be 15. The height of the solid one is going to be 15 by 2. I'm not making my smart moves by cancelling out h and h because it's going to be same or half of it. Let things be there so that everybody can understand. Capital R square 6.75 square minus 5.25 square. This is going to be pi multiplied by 15 by 2 multiplied by, we already have h. Do we have the radius? No, we don't have the radius of the solid cylinder, which we need to actually find out. So I'll let this remain as r. So pi gets cancelled with pi gets cancelled with pi, 15 gets cancelled with 15. Now here we need not calculate any squares. We'll use the formula of a square minus b square being equal to a plus b multiplied by a minus b. Okay, a plus b being multiplied by a minus b. When these two quantities get added up, I get the value of 12, right? And when these two quantities are subtracted from each other, I get the value of 1.5. Okay, so this is where I've landed, and I have r by 2 with me. This 2 goes here and makes it, this 2 goes here and makes it 3. So the radius, what I get here is 36. The radius, what I get here is 36. Right? Right? Good enough? Good enough? Good enough? So the value of small r, or the radius of the solid cylinder, is going to be 36, what? 36 centimeters. Right? Okay, let's move ahead. The volume of a cylinder is 1650 meter square, whereas the surface area of its base is 78 4 by 7 meter square. Find the height of the cylinder. There is a very peculiar thing about the surface area being multiplied by height. The surface area of the base, mind you, it's only talking about the surface area of the base. The base of a cylinder is nothing but a circle, and when I'm talking about the surface area of a circle, I'm doing nothing but talking about the area of a circle. So the area of a circle is nothing but pi r square. Area of a circle is nothing but pi r square. As soon as we talk about the volume, the volume of a cylinder is pi r square h. So it is essentially h being multiplied with the area of the circle. The area of the base multiplied by the height would give me the volume. Good enough? Understood? So I have the value of pi r square available with me, which is nothing but 78 4 by 7 meter square. I have my volume with me, which is equal to pi r square h, which is also equal to 1650, meter square. So I need to find out the height of the cylinder. If I divide the two equations, keeping the volume in the numerator and keeping the area or the surface area of the circle in the denominator, I'll get my answer. So this is nothing but pi r square h upon pi r square. This would be equal to 1650 whole upon. Now, if I have to convert this mixed fraction into a regular fraction, what would I do? 7 8s are 56. There is going to be a 4 there, so definitely a 0 would come here. So this would become a 60. 7 7s are 49. 49 plus 6 is going to be 50. No, 49 plus 6 is going to be 550. So this is going to become 550 upon 7. This seems to be a multiple of 11. That's for sure. 11 50s are 550. 11 ones are 11. 11 150s are 50 ones are 50. 53s are 150. So I get my height, because everything would get cancelled away. I get my height as 21 meters. And this is what I was looking for. Okay, good enough. In this question, there was no need to find out the radius. Okay, there was no need to find out the radius. If you were smart enough, if you get smart enough, you will definitely get smart enough with time. You will reach a point where you'll simply use the formulas, and after using the formulas, you'll achieve a point where you simply know that a regular division is going to solve your problem. Okay, A regular division is going to solve your problem. I'll move forward. Now, talking about the surface area of a cone. Okay, we're talking about the surface area of a cone. A cone is nothing but a birthday cap. Okay, a cone is nothing but a birthday cap. What happens in a birthday cap? It basically sits on your head, and there is a conical shape which comes up. There is a conical shape that comes up. So the cone has curved surface area, and it basically has a curved surface. This surface is called the curved surface, and this area is called a circular base. I'll straight away take you to the formula. The curved surface area of a cone is pi r l. Pi r l. As simple as that. Okay, this is the curved surface area of a cone. The total surface area of a cone is pi r multiplied by l plus r. Pi r multiplied by l plus r, where l is nothing but the slant height. Okay, l is nothing but the slant height. This thing which I have done in bold red, in dark red, is something which is called slant height. Slant height is almost, it's equal to the hypotenuse of a triangle when we see it in a 2D format. If I consider this to be in a 2D format, this is the height, this is the radius, and this being a right angle, because this is a right cone. Okay, this is a right angled cone. Most of the cones what we have in our syllabus are going to be right angled cones only. So this being a right angled cone, I have L over here, which is called the slant height. So L square is equal to r square plus h square. The value of L is going to be under root r square plus h square. Got it? So this is the curved surface area as well as the total surface area of a cone. Good enough? Let's move ahead. A cone has a slant height of 30 centimeters and a radius of 14 centimeters. Find the total surface area. The total surface area is pi r in the bracket L plus r. The value of pi is 22 by 7. The value of radius is 14. And the value of slant height is 30. The radius is 14. So 30 plus 14 is equal to 44. So this would become 7 to the 14. And I would have 42 into 40, sorry, 44 into 44 as my answer. So 44 square is nothing but 16 and 16. 4 4 is 16, 16 to the 32. Another 0 with it, 320. This would make it 1936. Okay, so 1936 centimeter square is my total surface area. The formula which I have written here is the total surface area of a cone, which is pi r multiplied by L plus r. Right? Let's move ahead. Now, a cone has a radius of 21 centimeters and a slant height of 25 centimeters. This is the radius we are talking about. Here is the center. This is the radius. Let me use a black pen. I think that will be a little better. Or let's use a white pen for now, because we are marking things on the inside, no? So this is the radius which we have. The radius is 21. The slant height that we are talking about, this is the slant height, okay? The slant height is actually slanting. Okay, the slant height is actually slanting. Let me use the red pen again. Okay, so this is the slant height. This is the slant height. The slant height is 25, and we need to find out the cost of painting its curved surface area at 1.5 1.5 rupees per centimeter square. 1.5 rupees per. Okay, so we have the slant height available, we have the radius available, and I need to find out the cost of painting its curved surface area. The cost of painting its curved surface area, and the price is given. So if I have a curved surface area, my answer would be pi r l. Pi is 22 by 7 multiplied by r, which is 21, multiplied by l, which is 25, and I'll quickly multiply it with the cost as well. Okay, 1.5. So 7 3s are 21. Mm, how should I use it? Okay, so 5 5s are 25, 5 2s are 10, 2 11s are. I have 15 into 15, that is 2 to 5. 2 to 5 into 11 is going to be my answer. So that's going to be 5, that's going to be 7, that is going to be 4, and this is going to be this. So 2475 rupees is going to be my answer. I hope everybody is able to understand it. Right? Let's move ahead. So here we had discussed about the curved surface area as well as the total surface area of the cone, and we had also discussed a very important concept of slant height. Slant height is basically the hypotenuse of a 2D cone. Okay, and the hypotenuse of a 2D cone, where the longest side, this longest side that I'm talking about, is going to be L. The height is going to remain intact, and there is a radius as well. So after doing that, now we'll be moving towards the volume of the cone. Okay, in a birthday hat, in a particular birthday hat, if you had to fill in water, or if you had to fill in any liquid in that birthday hat, so whatever amount of liquid that can be absorbed or that can be contained in that birthday hat is going to be the volume of the cone, right? So let me go ahead. So it's equal to one third the volume of a cylinder with the same base and the same height. So pi r square h is the volume of a cone, of a cylinder, and 1 by 3 pi r square h is the volume of a cone. Okay, L stands for slant height, and L is not going to be used in the volume formula. If the height is not given and you have to derive the height using uh, the using L and R, at that only in that situation L would come into the picture, and that too only for a very short duration. Okay, so I'll take you to the question now. You just need to remember 1 by 3 pi r square h. A conical vessel has a radius of 4 centimeter. The radius is going to be of 4 centimeters, and its curved surface area has already been given as 20 pi centimeter square. So talking about 20 pi being the curved surface area, the value of the curved surface area is pi r l. Okay, so 20 pi is equal to pi multiplied by r, which is given as 4, and multiplied by l. The pi and the pi get cancelled, the 4 and the 20 gets cancelled and becomes 5. So the value of l becomes 5 centimeters. I need to find out the volume. The volume is 1 by 3 pi r square h, which would ultimately lead to 1 by 3 pi r square h is something we have. So 1 by 3 multiplied by pi, which is 22 by 7, multiplied by r, which we already have as 4, and 4 into 4. Now we need the value of h. We need the value of h. Here we already know the slant height which came out of here was 5, right? This slant height was 5. So I need to find out the real height of it. The real height of it. The real height of it is going to be h. When I use the Pythagoras theorem here, I get 5 square is equal to h square plus 4 square. So the value of h from this equation comes out as 3. Why was I able to find out the value of 3 so quickly? Because I remember the Pythagorean triplet 3, 4 and 5. So I know the height is definitely 3. So multiplying it by 3. The 3 gets cancelled with 3. I would think it will be best for everybody if we could leave the pi as it is. So 16 pi centimeter cube is the volume that I'm looking for. Okay, this is the volume that I'm looking for, and this is the answer, right? Let's go ahead now. A cuboid of this dimension is melted and reshaped into a cone of height this. What is the radius of the cone? In this situation, we need to have the volume being equated with volume. The first volume would be that of a cuboid, and the second volume would be that of a cone. So cuboid versus cone. Cuboid versus cone. Now talking about cuboid. A cuboid of dimension 11, 8 and 6. Okay, 11 into 8 into 6. The volume of a cuboid, as we've already read, is L into B into H, and the volume of a cone, which we've already read in the past couple of minutes, is 1 by 3 pi r square h. So I have 11 into 8 into 6 being equal to 1 by 3 into 22 by 7 into r square, which we need to find out, multiplied by the height, which is 14. So this gets cancelled out. Yeah, this gets cancelled out at 2. This gives me another 2. This gives me a 4. This gives me a 2. And yes, I have 6 into 6, which is equal to r square. I deliberately did not multiply 6 into 6 because I wanted to show you that once we have a square, we need to, when once we have a square and we apply a square root on both sides, so 1 6 would come out of it. So my value, the value of my radius would come out as 6 centimeters. Okay, the volume of my cone, the radius of my cone would come out as 6 centimeters. Right? Good enough? All right, let's go ahead. Ah, so now if we cut off the top head of the hat, of the conical hat or the conical birthday cap that we were wearing, if we cut off the head, and this is where the cut has been placed. Okay, this is where the cut has been placed. Then we would get a figure that is called a frustum. Okay, so it is frustum is basically a portion of the cone between the two parallel circular surfaces, one being the new top surface and one being the old bottom surface. So I have a top base and I have a bottom base. In this particular situation, we would have again the same quantities of there being curved surface area, total surface area, as well as volume. If I talk about curved surface area, I have pi r plus r into L, or pi L multiplied by capital R plus small r. Why do we do that? Because we are taking into consideration the bigger radius as well as taking into consideration the smaller radius. Then talking about total surface area, the total surface area would be the curved surface area plus both the flat surfaces, or both the top and the bottom surfaces, the area of those. So pi capital R square and pi small r square. Okay, I hope you're able to understand. Good enough? Yep. Now talking about volume. The volume is 1 by 3 pi h multiplied by capital R square, small r square plus rr. So how you can actually remember it? You just need to remember this 1 by 3, which is coming with the help of any volume of cone. 1 by 3 pi h, it stays common across board. But when we are talking about the radiuses, the radiuses are going to come with the help of r square plus small r square plus capital R into small r. Okay, so this is something which you will have to memorize for the exam. Also, whenever we need to find out the value of L, or the slant height, the slant height is not going to start from the top now. The slant height is going to start from the top of the frustum now, not from the top of the cone, because the cone is no more in question. So the slant height starts from here and the slant height ends here. I've marked the 2 points. So this slant height L is going to be h square plus r square. But we don't have 1 hour this time. We have 2 hours that this time. So we'll take a difference of the 2 hours and then square it up. Okay. Difference of the 2 hours first, squaring to be done later. So that is how we would arrive at the value of slant height of a cone. In the root, or simply L square is equal to h square, which remains constant, plus the difference between the r squares. Right? Let's go ahead. Now, a frustum has a base radius. This is the base. It has a base radius of 4. It has a top radius of 2. Okay, I have still drawn a cone. When I had a frustum in mind, I still drew a cone, but need not worry. Let's assume the frustum is cut. Okay, the frustum is cut from here, and let's assume that this is the radius that we're talking about. This is the small r radius and this is the capital R radius. Now, do we have a slant height? Yes, we do have a slant height, which is equal to 6. Okay, we have a slant height which is equal to 6. I need to find out the curved surface area. I need to find out the curved surface area. Let me go back to the question. Pi L multiplied by capital R plus small r. Pi L multiplied by capital R small r plus capital R. The pi stands for 22 by 7 multiplied by 6, which is the slant height, multiplied by capital R plus small r. Capital R plus small r would also come out to be 6. This is the base radius, top radius, slant height L. So 22 by 7 multiplied by 36. So 36 pi is basically my answer. Let me recheck the formula. Yes, we've used the right formula. They've asked us for the curved surface area, so this is it. This is how easy and how conceptual and how important mensuration 3D is. Okay, going forward, the lateral surface area of the frustum of a right circular cone of the area, if the area of its base, okay, this is the lateral surface area. If the area of its base is 16 pi centimeter square and the diameter of the circular upper face is 4 and the slant height is 6, will be, let me see, I think the question is a little dense. It appears to be a little dense, but need not worry, it might not be as tough as it sounds. What do we need to find out? The lateral, see, the question is here. The lateral surface area of a right circular cone will be, frustum of a right circular cone will be, this is the question. So I need to find out the CSA, or the lateral surface area, which is pi L multiplied by capital R plus small r. Okay, this is the formula that I'm going to use. Further, it says the area of its base is 16 pi. That means the flat surface or the base on which it is kept, it is 16 pi. 16 pi is equal to pi capital R square. I can say that. So the pi and the pi would get cancelled. So the value of capital R comes out to be 4. So I have my capital R as 4. Now, I have the diameter of the circular upper surface. This upper surface diameter is 4. That means the small r radius is equal to 2. So, do I need to find out the base? Slant height. No, we already have the slant height. I have the value of slant height as 6. This would come out as pi multiplied by the slant height, which is 6, multiplied by capital R plus small r. Capital R is 4, small r is 2. So this comes out to be 36 pi. Okay, this comes out to be 36 pi. Good enough. Let's move on. We are done with the curved surface area as well as the total surface area of a frustum of a cone. So we basically now would be working on the volume of the cone. I've already taught you about it. 1 by 3 pi h multiplied by a small formula for the radii, the bigger radii square plus smaller radii square plus the multiplication of the other two radii. Okay, so we'll be quickly moving to the questions now. Okay, so the radii of the two circular faces of the frustum of a cone of height 21 centimeters are this and this. What is its volume? I'll employ the same easy formula, 1 by 3 pi h being multiplied by capital R square plus small r square plus capital R small r. So this would turn out to be 1 by 3 multiplied by 22 by 7 into 21, 5 and 3, right? They are the radii, 5 and 3. 5 makes a 25, 3 makes a 9, and 5 into 3 makes a 15. So this comes out to be 49. So 7 3s are 21. The 3 also gets cancelled. What I am left with is 22 multiplied by 49. 22 into 50 would give me 1100, right? Yeah, 22 into 50 would give me 1100. 1100 minus 22, that would give me 1078. Yeah, so 1078 centimeter cubes is the answer that I'm looking for. All right, 1078 centimeter cube is the answer that I'm looking for. Let's go forward. A metallic cone of radii this and height, this is melted and made into spheres of radius 4 centimeters each. I'll use the same formula of volume being equal to volume. In terms of spheres, we haven't learned about it yet. So spheres, we only have one dimension, which is r, which is radius. Okay, one unit dimension, I should say, or only one defining dimension, which is radius. Okay, and that when it goes in a 2D model, it becomes a circle. When it goes into a 3D model, it becomes a sphere. So the volume of the sphere is what we are interested in. So the volume of the sphere is 4 by 3 pi r cube. Mind you that in all the formulas of volume, there are going to be three quantities being multiplied with each other. If you only have one unit quantity or one defining dimension, that would be the only one. So three quantities would be multiplied by themselves. So when volume is equal to volume, I would say that 4 by 3 pi r cube is 4 cube multiplied by the number of total cubes that the number of total spheres that would come out. Also the cone, we already have a cone of some radius. So 1 by 3 pi r square is 16 into 16 square into h is 36. I need to find out the number of squares that I have. There's a very interesting thing that we have. If I multiply 4 with itself 4 times, or 4 raised to the power 4, then that is equal to 16 square. So both of them get cancelled out very easily. The 3 is gone with 3, the pi is gone with pi. So here I am left with n being equal to 36. Okay, n being equal to 36, which is my final answer. Right, let's go ahead. Now, talking a little more about frustum, volume of a cone, volume of a frustum, we've already talked about that. Okay, and the formula slide comes in multiple times. Okay, the formula slide comes in multiple times so as to help you remember all the formulas properly. Moving ahead, a solid metallic sphere of radius 12 centimeters is melted and recast into a cone having a diameter of the base as 12 centimeter. What is the height of the cone? We'll employ the same formula, the volume of cone being equal to volume of sphere, volume of cone being equal to volume of sphere. So what's the volume of sphere that we are looking at? The volume of sphere is nothing but 4 by 3 pi r cube. The value of r is 12, so I'll write 12 cube over here. And the volume of cone is 1 by 3 pi r square. R square is not 12 square, r square is 6 square. Okay, 1 by 3 pi r square and h. H is something which I need to find out. I'll quickly do my easy calculations. This is 36 and this is 144 into 12. So 36 ones are 36, 4s are 144 into 12. Okay, I hope this is not a tough call for you to understand what I'm talking about. I have the height being equal to 16 into 12. So I have 16 2s are 32, 16 1s are 16, so it would be 192 centimeters. Let me still see if we have made a mistake. 1 by 3 pi r square and h and 4 by 3 pi r cube. 12 into 12 into 12. Yeah. So 6 2s are 6 2s are, we get a 4 out of here. So this is 16 into 12. Yeah, this is fine. This is fine. So the height comes out to be 192 centimeters. All right. The height comes out to be 192 centimeters. Moving ahead, a conical vessel whose internal radius, this is a conical vessel we are talking about, and this is the internal radius that we are talking about, is 20 centimeters, and its height, this is the height that we're talking about, is 27 centimeters. This is the radius, this is the height, is full of water already, and this water is poured into a cylindrical vessel with internal radius 15. This is the internal radius, which is 15. What is the height till which the water will rise? So this internal radius is valid till the bottom as well. It's going to remain the same in the bottom as well, because it is a right angled cylinder. Okay, it's a right cylinder. The curves, the height isn't bending in any direction, it is standing straight. So when I have that and I have a cone which is full, I have a cone which is full and I am now going to pour it down. I don't know the height of the cylinder till what the water will be there, but I'm sure about one thing. If I equate the volume of the cone being equal to volume of the cylinder, volume of the cone being equal to the volume of cylinder, we will reach a point when the cone empties itself completely and the cylinder fills itself to a level where the height is appropriate enough, or the height is big enough to absorb all the water from the cone, or to contain all the water from the cone. Okay, so we just need to simplify the things, and volume of the cone is equal to volume of the cylinder. So when we say whose internal radius is 20 centimeters, we're talking about the conical vessel, which is going to be 1 by 3 pi, 1 by 3 pi. What is r square? R square is 20 square. What is h? H is 27. Okay, there is a multiplication sign in the middle. This would be equal to pi. What is r square? R square would be 15 square. And what is h? That we need to find out. Right? So the pi gets cancelled with pi. Now I have 15 square and 27. So 15 is made up of 15 square is made up of 25, 5 and 5, 25, 25 multiplied by 9 into h. This would be equal to 40 into 27. This is not 40, this is actually 400 that we're looking at. Okay, let me not write it this way. Let me write it 400 directly. Let me write 400 directly. This is 400 into 27 upon 3. 3, this becomes 9, 9 is gone, this is 24, 25, 25 4s is 400, 25 16s is 400. So the value of h that we are looking at is 16 centimeters. So the height till which the water would rise would be 16 centimeters. There's not much complicated calculations involved in this. The calculations are always going to be easy. The only thing which might be complex would be the concept. Okay, as water is flowing out from the cone to the cylinder, some people might get confused. It's nothing, it's a simple volume transfer question. The volume of cone is being transferred into the volume of the cylinder. Okay, let's go ahead. The curved surface area of a cone is 5940. So I have pi RL being equal to 5940. The radius is 21. We already have the radius 22 by 7 into 21, and a simple question of slant height has been asked. This L I need to find out. This L I need to find out. This is 7, this is 3 is 21. So I have 11 2s are 22, 11 54s are 594, and I have a 6, this is 90. So the value of L is nothing but 90 centimeters, right? The value of L is nothing but 90 centimeters. Good enough? Let's go ahead. Now, surface area of a hemisphere, be it solid or be it hollow. So whenever in the case of hemisphere, what really happens is that it's a sphere which is cut into two equal parts. If we have a complete sphere, the surface area or the total surface area would remain the same. The total curved surface area or the total surface area would remain the same, which is going to be 4 pi r square. When we talk about only the curved surface area of a hemisphere, we talk about CSA, which is 4 pi r square upon 2. Okay, because it's going to become 2 pi r square. Similarly, if we talk about the total surface area in this case, we would reach another flat surface, which is this top surface. we'll be talking about this top surface. So this top surface is nothing but a small circle, and the area of a circle is nothing but pi r square. So this pi r square is going to get added up to the 2 pi r square, and it would become a 3 pi r square. Also, now talking about the hollow hemisphere. In hollow hemisphere, we have a curved surface area. The same formula would be applied, that 2 pi would definitely be in the picture, but there would be a difference in the squares of the radii. Difference in the squares of a radii because it is hollow. Talking about the TSA, the total surface area, it is going to be 3 pi capital R square minus small r square. I've already told you the reason of there being a difference in the radii, or the squares of the difference of the radii. Okay, or difference of the radii is squared. This is a more proper way of saying it, right? I hope the formulas have been memorized. Let me go ahead. We have this hemispherical bowl, and it's made of iron, and it has an inner diameter of 84. The inner diameter of 84 means an inner radius of 42. Okay, this inner radius is valid till here as well. It's valid everywhere inside it. The cost of tin plating. The cost of tin plating it on the inside at rupees 21 per 100 centimeter square is what? So I'll simply have to find out 2 pi r square. I'll simply have to find out 2 pi r square. This 2 pi r square is nothing but the curved surface area of a hemisphere. 2 pi r square, 2 multiplied by 22 over 7 multiplied by 84, no, multiplied by 42 into 42. This is the internal area that we are talking about. Now, for each and every 100 centimeter square, I would be paying 21 rupees. I would be paying 21 rupees. So I'll quickly manage this here, and I'll let the 100 stay here. I have 42 square multiplied by 6 into 21 into 22. So 22 into 42 square into 6 upon 100. I'll do the 42 square. The 42 square is nothing but 1604. 4 to the 8, 8 to the 16, 16. This is 160. This is 4. This is 1564. 1564 into 22 over 100. So it would be 2 4s are 8, 2 6 are 12, 2 5s are 10, 11, 2 1s are 2, 3, 3 1 2 8. Now the 8 is going to stay here. This is 8, 2s are 10. This is 3, and this is going to become 4, and this is also going to become 4. This is going to be this. So 34408 is the 34408 upon 100. So 344 rupees, 344 rupees and 8 paise, or 344.08 rupees is going to be my answer, right? I hope you were able to understand this. Okay, let's go forward. Yeah, so the internal diameter of a hollow hemispherical vessel is 24. It is made of a sheet which is 0.5 centimeters thick. What is the TSA of the vessel? So I have a component of a thickness being available there. So this is where the radius ends, and this is where the internal radius ends. This is the, I'll point it out. Okay, this is the internal radius, and this is the outer side of it. Internal and outer side of it. Internal and outer side of it. And this thickness is what we're talking about being 0.5 centimeter thick. I need to find out the thickness of the vessel. I'll go back to the formula just to check if we are right. The total surface area is 3 pi multiplied by capital R square minus small r square. Okay, so the formula that we'll be employing is 3 pi multiplied by capital R square minus small r square. This is going to be 3 into 22 over 7 multiplied by capital R square. This is a diameter we are talking about. So 12 is the internal radius. So it's going to be 12.5 whole square minus, this is a bigger radius, talking about the internal radius, it's going to be 12 square. It's definitely possible to find out the square of 12.5, but we'll be avoiding that situation. We'll be using the formula a square minus b square being equal to a plus b and a minus b, a plus b and a minus b. This is going to be 24.5 when it is added, and this is going to be 0.5 when it is subtracted, or I'll simply write 2 or half, right? So 3 into 22 over 7. I'll use a 10 over here in the end. So this is 7 ones are, and I use the 10 to remove the point from here, and this is 7 threes are 21, 7 fives are 35. I have a 2 here, I'll let this be 11. Do I need to fiddle with it anymore? I don't think so. So we have 385 multiplied by 3 whole over 10. 385 threes are 3 fives are 15, 3 eights are 24, 25, 3 threes are 9 and 11. So 1155 upon 10, which gives me the answer triple one or double one 5.5 centimeter square. This is the total surface area we were talking about. Okay, hemispherical vessel with a total surface area. Let's go ahead. A solid sphere has a radius, has a surface area of 616 centimeter square. The sphere is now cut into two hemispheres. What is the total surface area of one of the hemispheres? Some people are simply going to cut it into two parts, 308, and say that one of the hemisphere is equal to 308. But we are missing out on a very essential point. That essential point is when the hemisphere is broken, when the sphere is broken into two parts, there is a new flat surface that is occurring on both the sides. If you know the area of that flat surface, you can easily add it up with the curved surface area of one half of the hemisphere and let that be here. So for that particular reason, the sphere is now cut into two hemispherical halves. So the solid sphere has a surface area of this. So I'll use the solid sphere surface area, which is nothing but 3 pi r square or 4. No, it's 4 pi r square. 4 pi r square is the curved surface area of a sphere. So the value of 4 into 22 over 7 into r square is equal to 616. So this goes by 11 5s are 55, 11 6s are 66. This is 11 2s are. This is 8, this is 7. So the value of r square is 7 into 7, or simply the value of r comes out to be 7. If I have my r being equal to 7, I can find out the area of the flat surface which occurs over here. I can find out the area of the flat surface which occurs over here, and or I can simply find out the area of the hemisphere. The area of the hemisphere is nothing but, or the total surface area of one hemisphere is 3 pi r square. So 3 into 22 over 7 into 7 into 7. Both these things are gone. So 3 sevens are 21. 21 into 22. So 21 twos are is 42. 21 twos are is 42. 42, this is 462. So 462 centimeter square is the area that I am looking for, right? 462 centimeter square is the area that I am looking for. Good enough? Let's go ahead. Volume of hemisphere, direct and reverse radius problem. Okay. Yeah, a solid hemisphere occupies half the volume of this, the domes, tanks and everything. Formula: solid hemisphere. We are talking about the volumes. Okay, we're talking about the volumes now. So 2 by 3 pi r cube, and there is a reverse formula which is to find out the value of r. So I don't think this is necessary. It's okay if you can remember this formula. I told you 4 by 3 pi r cube is the formula of full solid sphere. Similarly, um, For a half solid sphere or a hemisphere, we have 2 by 3 pi r cube. Okay, this is hemisphere, right? Let's go ahead. The volume of a solid hemisphere is this. What is the total surface area? I'll quickly write down the formula first. 2 by 3 pi r cube is equal to 19404. 2 by 3 into 22 over 7 into r cube is equal to 19404. This is 11 twos are 22, 11 ones are 11, 84, 11 sevens are 77, 77, and we have another 70 here. 11 is 66, and this is going to come here. Can we divide it by 4? The answer is yes. We'll have 4 fours are 16, and another 4 fours are 16, and 1. So we'll get r cube as 441 multiplied by 21. 441 is basically nothing but 21 square. So the value of r cube is equal to 21 cube, and the value of r comes out to be 21. The question doesn't end here. We'll have to find out the total surface area. The total surface area of a hemisphere is nothing but 3 pi r square, 3 into 22 over 7 into r, which we've just found out as 21 into 21. The 7, this is 3. Yeah. So we have a 9. 21 into 22, 21 twos are 42. This is 462. This is 462 multiplied by 9. We will get 9 twos are 18, 9 6 are 54, 55, 9 4s are 36. This is 41. So 4158 centimeter square is the total surface area that we are talking about, right? This is the total surface area that we are talking about. Good enough? Let's move ahead. Now, the volume of a hemisphere is given. I quickly need to find out just the radius. Volume of a hemisphere is 2 by 3 pi r cube, which is equal to 486 pi. 2 by 3 into pi into r cube. This is equal to 468 pi. The pi gets cancelled with the pi. I just have a 2 here. This is going to be 2 2s are 4, 2 3s are 6, 2 4s are 8. So the value of r cube is going to be 234 into 234. No, this is going to be 243. This is not 234. I just changed the value. This is 468. So 243. This is going to be 243 into 3. 3 3s are 9, 3 4s are 12, 3 2s are 6, 7. This is 729. 729 is basically the cube of 9, because 81 into 9 is 729. So the value of r cube is nothing but 9, or the value of r is nothing but 9. We had to find out the radius, and we found the radius. Good enough? Let's go ahead. Okay, how many liters of water can a hemispherical tank of radius 2.1 meter contain? How many liters of water can a hemispherical tank of radius this contain? 1 meter cube is equal to 1000 centimeters cube. Okay, this is 1000. No, this is going to be 1000 and another 1000 with it. So 10 lakh. This is going to be 10 lakh centimeter cube. So we are talking about meters itself. So this conversion was not very useful, but yes, you have to remember this for the exam. I can simply employ this in the formula. We're talking about a hemisphere. Hemisphere is 2 by 3 into pi, that is 22 over 7, into r cube, which is 21 into 21 into 21. There is going to be the concept of 1000 being there. 3 sevens are 21, 21 gone. This is 441 multiplied by 44. 441 being multiplied by 44. This would give me a 44 ones are 44. 44 fours is 176. 176 gives me an 180. 44 fours is again 176. 176 plus 18. 184, 184. So 19404 is going to be my answer. Okay. So 19404 is going to be my answer. Good enough. Let's go ahead. Now talking about a solid sphere. A solid sphere would have the curved surface area or its surface area as 4 pi r square. The hollowness would give it a difference of the squares of the radii. The volume would remain here and the volume of a hollow sphere has been written here. I've already taught it, so I won't be repeating it here. You can pause the video, look at the formulas, and then we'll go forward. Now, the total surface area of a sphere whose volume this is what? We're talking about the total surface area of a sphere. So 4 pi r square is what we're looking at. 256 upon 3. The pi gets cancelled away. 4 6 are 24 and 4 4s are 16. Oh, I'm so sorry. We are dealing with volumes, and I was assuming it to be the surface area first. We need to find out the total surface area. If we are talking about the volume of a sphere, we would use the formula 4 by 3 pi r cube being equal to 256 upon 3 pi. The pi gets cancelled away, the 3 is gone. This 4 converts itself into 4 8 4 no, 4 6 are 24 and 4 4s are 16. The value of r cube is 64 and the value of r is nothing but 4. As we have the value of r being equal to 4, we just need to find out the value of 4 pi r square. 4 into 22 over 7 into r square, which is 4 into 4. Let me assume this to be pi only. I can easily say, because they are already using something in the terms of pi, then I believe it is much easier and more relevant for us to use the answer in pi. So this is nothing but 64 pi centimeter square, and this is the answer that I was looking for, right? Let's go ahead. The curved surface area of a sphere is 154 centimeter square. Find the volume of the sphere. We're talking about curved surface area. Curved surface area of a sphere means 4 into 22 over 7 into r square. Once we have the radius, once we have any base quantity, we can reach any heights. We can go towards volume, we can go towards curved surface area, we can go towards total surface area. So that's all the possibilities open up once we have the main linchpin, and this is the main focus of ours, that we need to get the value of r. This is 154, right? 11 2s are 22, 11 14s are this is going to be 2 7s are 14. So r square is equal to 7 into 7 whole upon 4. This would give me a value of 7 upon 2. This is the value of r. I need to now find out the volume of the sphere. Volume of the sphere. 4 by 3 pi r cube. All the 3 2's go and leave this behind. This and this go. So this is 49 into 11 over 3. 49 into 11 over 3. 11 9s are 99. 11 4s are 44. 11 9s are 99. 11 4s are 44. Okay, we have 99, we have 44. 11 nines are 99, 11 fours are 44, 44 plus 9, um, okay, 44 plus 9 is 53. 53, so 539 over 3 is going to be my answer. I'll see if it can be cut off. I don't find any point in cutting it here. Okay, no cancellations available. So 539 upon 3 is going to be my final answer. Right? Let's go ahead. A hollow sphere has an outer radius of this and an inner radius of this. What is the volume of this hollow sphere? So 4 by 3 pi, we'll check the formula for capital R cube minus small r cube. Is that what we're looking at? Capital R cube is 6 cube minus small r cube is 3 cube. So 4 by 3 into pi into 6 cube minus 3 cube. 3 cube is 27, 6 cube is 216. So when I subtract things like that, I get a 9 here and I get an 18 here. I get an 18 here. So 189 is what we're dealing with. 4 by 3 into 22 over 7 into 189. 7 2s are 14, 7 7s are 49. So 3 9s are 27. 9 2s are 18 and 9 2s are 18, 198 multiplied by 4. So 200 by 4, 200 multiplied by 4 would give me an 800. 800 minus 8. So that would give me 792 centimeter cube. This is my final answer. Right? Let's go ahead. The volume of a solid sphere is this. What is its surface area? 4 by 3 into pi into r cube being equal to 4500 pi. The pi and the pi get cancelled away. Do we have anything else? If I multiply it by 3, I don't get anything which is useful for me. Solid sphere. 4500 into 3 whole upon 4. This is what we're looking at. 2 to 5 into 3. I'll have to factorize it in a manner where I can get some benefit out of it. I would get 25 into 45 into 3. So if I have 25 into 5, this would give me a 5 cube, and this entire story would then get multiplied with 9 into 3. This would give me a 3 or a cube root of 3. So 5 into 3 is what I'm looking at, which is nothing but 15. I get the value of my radius as 15. I need to find out the surface area. 4 pi r square is what I'm looking at. So 4 into 15 into 15 into pi is the answer. 15 4s are 60. 60 15s is 900. So 900 pi is my final answer. Right? That's going to be my final answer. Okay. A hollow sphere has an outer radius of 4 centimeters and an inner radius of 1 centimeter. What is its volume? 4 by 3 pi capital R cube minus small r cube. We are talking in the terms of pi, so I'm not going to dissociate the pi. I'm not going to break down the pi into its real 22 by 7 parts. So r cube minus r cube, capital R cube minus small r cube, which is 4 cube minus 1 cube. So 4 cube is 64, 64 minus 1 is 63. So 4 by 3 pi into 63. This is going to give me a 21, and I would end up with 81 pi centimeter cube as my answer. No, this is not 81, 84 pi centimeter cube as my answer. Okay, 84 pi centimeter cube is my answer. Moving ahead. Now, This is nothing. This is the same thing being done in reverse. Okay, this is the same thing being done in reverse. You just need to remember the one formula that we've taught, and we are going to use the same formula further ahead. Let x centimeter square be the surface area and sphere. Okay, we are talking about sphere. So 4 pi r square is the surface area, which is equal to x, and y cube and y centimeter cube, which is y being the volume. 4 by 3 pi r cube. Okay, such that y is equal to 14x. So if I write y 4 by 3 pi capital R cube being equal to 14 times x, 14 into 4 pi r square. The pi and the pi are gone, the 4 and the 4 are gone, and this r cube is going to remain, and this r square is going to go, and 3 would get multiplied here. So the value of r is going to be 42 centimeters. This is what we are looking at. Okay, so this is what we are looking at. Going ahead, the radii of two solid spheres are 1 centimeter and 6 centimeters. They are melted to form a hollow sphere of outer radius 9 centimeters. A hollow sphere of outer radius 9 centimeters. I just need to find out the. So if there is a melting going on, so I can say that volume 1 would be equal to volume 2 plus volume 3. The volume 1 being the 9 centimeter sphere, the volume 2 being 1 centimeter, and the volume 3 being 6 centimeter, right? So I'll first find out the volume 1 and volume 2. Volume 3, volume 2 and volume 3, 4 by 3 pi r cube. 1 cube is 1, so I'm not writing it. This is another 6 cube, which is 216. Okay, so they would get added up. This is equal to 4 by 3 pi capital R cube, which is 9 cube, minus small r cube, right? So once this gets added up, I would be 4 by 3 into pi into 217 being equal to 4 by 3 into pi being multiplied by 9 cube minus r cube. The pi gets cancelled with pi, the 4 is gone with 4, the 3 is gone with 3. So the value of 217 is equal to 9 cube. 9 cube is 729 minus r cube. So the value of small r cube is going to be 729 minus 217, which is going to be 512. So the value of r cube is equal to 512, and the value of r is going to come out as 8. So if I have an outer radius or capital R being equal to 9, and I have an inner radius or a small r which is equal to 8, so capital R minus small r, capital R minus small r is equal to 1, is equal to 1. So this is what we are looking at. Fine, this is what we are looking at. Capital R minus small r, which is equal to 1. Happy? Let's go ahead. A hollow metal sphere of internal and external radii, this and this, is melted to form a cone of some base radius. What is the height of the cone? Again the same. Volume 1 is equal to volume 2. 1 being a metal sphere and 2 being a cone. The cone's volume is 1 by 3 pi r square h, and the hollow metal sphere's volume is 4 by 3 pi capital R cube minus small r cube. Capital R cube is 6 cube and small r cube is 5 cube. So 6 cube is 216, small r cube or 5 cube is 125. The pi would remain here, 4 by 3 would come here, 1 by 3 pi 52 into 52 into h. 52 into 52 into h. The pi and everything, they go away. 216. Had it been 215, I think 109 would be the answer. Yeah, 109. Yeah, 109. So 109 into 4 is equal to 52 into 52 into h. There is a component of 100 as well. There is a component of 100 as well. 13 fours are 52. Yeah, 13117. No, this is not going to help me. I'll still have to do it. This is going to be 436 over 52 square. This would be multiplied by 100. This would be h. 52 square is nothing but 25045 to the 10, 10 to the 20. This is going to be 200. So 2704. So this is 2704. This is what we are looking at. So 4 ones are 4 fours are 16 or 4 sevens are 28. Yeah, 4 ones are 4. This is 4 sevens are 28. So somewhere around a little less than 28. So this is not going to be 7. This is going to be lesser than 7. So if something is lesser than 7, 1.69 something. So I think D. D is going to be my final answer. Right? D is going to be my final answer. Let's go ahead. Now, talking about prisms. So prism is basically a figure which has two identical bases and vertical faces. They are called the lateral surfaces. So the base can be a triangle, square, trapezium, or anything. We've already learned about those 2D figures. We need to know the surface areas or simply the areas of those 2D figures. And when we multiply that with the height, that is when we find out the total surface area. Okay, that is when we find out the total surface area. So yes, we've been talking about the prism. The prism is nothing but, see, you can consider this. This is a square. If I extend it till here, no, this is a square, right? This is pretty much a square. If I extend it till here and add a depth to it or add a height to it, that is when it becomes a prism. So any 2D figure which is given a height and it extends itself into creating a 3D figure is called a prism. So everything that we've read before is a prism only, except a cone. A cone is not a prism. A cone is a type of a pyramid. Okay, a cone is a type of a pyramid. When we usually, most of the prisms that we read about have triangular bases. Okay, most of the prisms that we read about have triangular bases. Got it? So to find out the curved surface area or the lateral surface area, we need to have the perimeter into height, the perimeter of the base into height. And to find out the total curved surface area, we need to have the curved surface area plus twice into area of the bases that we've considered. Also, to find out the volume, we need to have area of the base being multiplied by the height. Okay, being multiplied by the height. Moving ahead. Okay, we have a right prism. It has a height of 18 and its base is a triangle with 5, 8 and 12 as its sides. What is the lateral surface area? Talking about the perimeter multiplied by height, this would give me the LSA. This would give me the LSA. Talking about the perimeter is 5 plus 8 plus 12, which is equal to 25. Talking about the height has already been given as 18. So this would come out as 450. So 450 centimeter square is the lateral surface area that we've been talking about. Right? Let's go ahead. A prism has a regular hexagonal base whose side is 12 centimeter. The height of the prism is this. It's cut into four equal parts by perpendicular cuts. What is the sum of the total surface area of the four parts? Okay, we have a hexagon here. We have a hexagon here, and the height of the prism is 24. Hmm. The base side is 12. The base side is 12. If this is 12, this is going to be 6, this is going to be 6, this is going to be 12, this is going to be 12, another 6, another 6, and another 12. Hmm. The only tough part is to find out this particular line. If I connect all the dots together, hmm, this is when we get. So for a prism we have already completed the area, the curved surface area, the total surface area, the lateral surface area. Now we'll be moving towards the volume. We'll be moving towards the volume of a prism. So what happens is, I've already talked about the curved surface area or the lateral surface area. In those cases, we were using the perimeter of the base, multiplying it with the height, which, see, when we have a 2D figure, the maximum that we can achieve out of the 2D figure is maybe the perimeter or maybe the area of the base. That is the maximum thing we can achieve out of it. There is no concept of volume in a 2D figure. But when a 2D figure transforms itself into a 3D figure, like a circle can transform itself into a 3D figure by spinning on its own axis and creating a sphere, or a circle can travel in a straight line, and with the ends of its diameter it can convert itself into a cylinder. So what usually happens is, if we are only talking about the perimeter, if we are only talking about the perimeter of a circle, or that is also the circumference of a circle, and we extend it using the height or make it move in a linear fashion up to some distance, let's say h, so 2 pi r multiplied by h would give you the curved surface area. So the same concept goes out for all the volumes of prism as well. When we were talking about the base perimeter multiplied by the height, we were talking about the lateral surface area or the curved surface area. But in terms of prism, when we are talking about volumes, the we have to have the surface area or the base area, and in the base area we have to multiply it by height. When the base area is multiplied by height, that is when we achieve the volume. Okay, so that is what we are talking about. Volume is equal to base area multiplied by height. Talking about common base area formulas, some of them being right angle triangle, half into base into height. For a square it's a square, for a rectangle it's l into b, for a regular hexagon it is root 3 by 3 root 3 by 2 a square, or as simple as that, root 3 by 4 a square is an equilateral triangle. And when it is multiplied by 6, because there are 6 equilateral triangles in a regular hexagon, so this is a better way to remember the formula. Okay, for a trapezium, half into sum of parallel sides into height, right? Half into sum of parallel sides into height. So we'll be moving forward with the same zeal and the same concepts, right? So let me quickly take you to the upcoming point, right? Just a second. Just a second. Yeah, I hope things are visible now. Okay, so in the previous slide we talked about this, which wasn't visible in the beginning, but now I think it is visible. Okay, we were talking about a circle, its base perimeter, its base area, when multiplied along the linear height, that is when we achieve the volumes. Okay, So same thing over here for a regular hexagon, root 3 by 4 a square multiplied by 6, because there are 6 triangles which we have to account. Okay, there are 6 triangles which have to be accounted for. Moving forward, I'll take you to the question now. The base of a right prism is a triangle with sides 16, 30 and 34, and the height is 32. What is the lateral surface area and volume? So let me first check. I have 16, I have 30 and I have 34. Does this couple, or this triangle, or this trio, does this trio make up for a Pythagorean triplet or not? If it makes up for a Pythagorean triplet, then I can simply apply half into base into height. If not, we have the option of applying for Heron's formula. Okay, we have the option for using the Heron's formula in this case. So I can see a common element of 2 here, so I can have 8, 15 and 17. Yeah, I've taken 2 common out of all the sides, so 8, 15 and 17, and for sure 2 to 5 plus 64, which is 15 square plus 8 square. This makes for 289, which is the square of 17. So I'm very sure that this is a Pythagorean triplet. This eases down my job, because area of a triangle is nothing but half into base into height for all triangles which are right angle triangles. Okay, so half into base into height, which is equal to half into 16 into 30. This gives me 240 centimeter square as the area of the triangle. Talking about the perimeter of the triangle, for the concept of perimeter, we have to add up all the sides. When I add up all the sides, I get 80. 80 is my perimeter. So 80 centimeter is my perimeter. Now I just need the component of height in this. The component of height is equal to 32. Okay, let me write the height equal to 32 over here. When I multiply the area with height, I achieve volume. When I multiply area with height, I achieve volume. 24 2s is 48 and 24 3s is 72. 72 plus 4 is 76. So 7680 is my volume. This would be in the units of centimeter cube. When I multiply perimeter with height, I am given the LSA, or the lateral surface area, and 8 2s are 16, 8 3s are 24. So 2560 centimeter square. This comes out to be my lateral surface area. So this is how the entire situation pans out. Okay, you just need to know the perimeter, you just need to know the area. So once that is clear in your mind, I believe we can achieve a point where we can go forward very smoothly, right? Let's go on. The base of a right prism is a triangle whose sides are 8, 15 and 17. Looking at it, very clear that it is a Pythagorean triplet. That means most assuredly my triangle is a right angle triangle. Okay, so 8, 15 and 17. And its lateral surface area, the LSA, has already been given as 480. Now I need to find out the volume of the prism. For volumes, I need to have area, or the base area, into height. Let me write the word base here. The base area into height. For LSA, which I already have, I have base perimeter into height. So if I need to find out the base area, I can find that out by simply doing half into base into height. The base stands at 15 and the height stands at 8. This gives me the value of 60 centimeter square as the base area, right? 2 4s are 8 and 15 4s are 60. So I have 60 centimeter square as my base area. Now I need to know the height. The height hasn't been given to me in the question. Talking about the base perimeter into height, which equates itself to the LSA, what would I do? I would say the base perimeter is something which I know. The base perimeter is 25 plus 15, which is equal to 40. So 40 into height is equal to LSA, which is 480. The 0 is gone with 0 and the height comes out to be 12 centimeters. The height comes out to be 12 centimeters. So now I have the base area and I also have the height. So I can find out the volume quickly, and the value of volume comes out to be 60 multiplied by 12, which is equal to 720 centimeters cube. Okay, why is it cube? Because 1 centimeter square or 60 centimeter square is coming from this side and 12 centimeter is coming from the other side. So 720 centimeters cube. Got it? Let's move on. Now, talking about the further points. In pyramid, we've already talked about a prism, and prism is a generally available in all the other options. In all the figures that we have, in all the 3D objects we have, if it is very symmetrical, that means it is a prism in a way, right? But talking about pyramids are nothing but cones. Okay, pyramids are nothing but cones. The only difference is that in most of the pyramids we have polygons and not circles. Okay, we have polygons and not circles, and the sides from the base come and meet at a point. Okay, the straight lines which start from the base come to the top and meet at a point. So usually all the areas which form a tent, which form a tent like situation, they fall under pyramids. Okay, they fall under pyramids. So talking about the entire situation of how pyramids come about and how things come up, so let me take things forward and teach you about it. Yeah, so the points which need to be taken care of, the points which need to be taken care of are the ones here. Whenever we talk about the lateral surface area of a pyramid, then area of all side faces is what we are talking about. You'll have to calculate the area of one of the sides separately, and once you have the side face with you, you have to simply multiply it by 4. Okay, when you have one of the side faces with you, you have to multiply it by 4, and that is how you achieve it. Talking about the total surface area, the total surface area would have the lateral surface area added with the base area. The bases are usually rectangle or square or maybe even triangle in a few cases, so need not worry about it. We are following the same concept. Okay, we are following the same concept. Now talking about the other formulas, LSA or the lateral surface area of a pyramid is equal to half into the perimeter of the base into L. L stands for slant height. Okay, this slant length that you can see, this is also called the slant height, and there is a concept of slant edge as well. Okay, there is a concept of slant edge as well. If you can see, this entire line, I'm drawing very slowly, look at it very carefully. This is one of the edges. Okay, this is one of the edges of a pyramid. So these edges are called slant edges, and the height of one of the faces, the height of one of the faces of the triangle, the height of one of the faces of the triangle is basically called the slant height. Okay, if you wish to calculate, I'll have to change the color of the pen. If you wish to find out the slant height, in that case you would have to have half of the length of the base with you, because this is a by 2. I'm assuming that the base figure that you see over here is a square, so the side of the square upon 2 will form the base of the triangle in which you can apply Pythagoras theorem. The height, the real height of the pyramid starts from the top of the pyramid till the core of the pyramid. So this is the top of the pyramid and this is the core of the pyramid. So from the top till the bottom, that is the height that we're looking at. When we are looking at one of the faces of the pyramid, that at that point you have to declare the center line to be the slant height. But if you're looking at one of the corners of the pyramid, when you're looking at one of the corners of the pyramid, at that time you have to declare that corner edge to be the slant edge. The formula differs for both of them. We have a by 2 as the base, we have h as the height, and whenever we talk about slant height, we use it as L. Now, if we talk about slant edge, the edge has a different sort of an orientation. The line which is meeting from one of the corner vertices to the center or to the core of the pyramid, that line is not going to be half of the side of the square base. That is going to be half of the diagonal of the square base. So this would come out to be root 2a by 2, because root 2a is the complete diagonal, but we are going to only use half of the diagonal. That means this comes out to be a upon root 2. Okay, this comes out to be a upon root 2. Once we have that a upon root 2, the height of the entire structure remains the same. The height remains the same. We have a upon root 2. Then the corner that we were talking about, the corner edge what we were talking about, becomes the slant edge. We can again apply the Pythagoras theorem and get what we want out of it. So slant height is equal to h square plus a by 2 whole square. In the third slide from here, you'll get the height, or basically the slant edge being equal to the height square plus a by root 2 whole square. This is the only difference in this formula and this formula. Okay, there are two formulas. One of them will calculate the slant height, the other one would calculate the slant edge. Just a small trick to remember it. Slant edge is a more difficult concept. Slant edge is something which you find a little more complex. That is why in the same formula of slant height, instead of using a by 2, you have to use a more complex term, which is a by root 2 whole square. Then talking about slant height, in that concept, it is an easier concept. So we need not have any roots in the question. So a by 2 whole square would suffice. Got it? I hope this is enough. Now I won't be talking about the volume, because volume is going to be nothing but the area of the base multiplied by the height. Okay, volume of the base multiplied by the height, area of the base multiplied by the height. So the base of a right pyramid is a square of side 10. So this is a square which I can see the side is 10. I'll just have a better color for it. Yeah, this is 10 here, and this is the center or the core of it. This is 10, this is another 10, and this is another 10. We have all 10s over here, and there is a center point over here. So now we need to find out the lateral surface area, and the height of the pyramid is also 10. I am making this jiggly height, this jiggly wiggly height, only because I want you to clearly see of what is going on, what is actually going on. So this is 10 centimeters again. To find out the lateral surface area, we need to have half into the perimeter. Let me see if that works here. Yeah, LSA is half into perimeter of the base into slant height. Half into perimeter of the base into slant height. So the perimeter of the base multiplied by slant height. The slant height in this case would come out to be this, and this is nothing but 5. The real height is 5, the real height is 10, the base is 5, and using the Pythagoras theorem I can find out the value of slant height here, L being equal to 10 square plus 5 square, which is root 125. So I will keep the root 125 as 5 root 5. So my L becomes 5 root 5. The perimeter of the base is 40. So 40 upon 2 into 5 root 5. This gives me my answer as 100 root 5. Okay. So this is the lateral surface area of the pyramid that I'm talking about. Let's move ahead. Now, the base of a right pyramid is an equilateral triangle with an area of 16 root 3 centimeters square. So root 3 by 4a square, which is the area of a triangle, is equal to 16 root 3. The root 3 and the root 3 get cancelled. 16 4s are 64. So the value of a comes out to be 8. centimeters. Now, if the area of one of its lateral faces, I'll be opening up the pyramid today. So when I open it up, I would open up all its branches outside. I would open up all its branches outside. So once the branches are all opened up, the value of A, the area of one of its lateral faces is 30. Right? The area of one of its lateral faces is 30. So I have the base as 8. I need to find out this height. No, the real height which I need to find out is this one. But the slant height is something which I would get because I'm talking about the lateral faces area. The lateral faces area is 30, which is equal to half into the slant height multiplied by the base, which is 8. Now this would come out as 4 and I would get the value of L as 7.5 centimeters. Now this is 7.5 centimeters till the center. This line which you can see over here, I'll change the color. This baseline which you see over here is a right angle triangle. This is the same baseline that we are talking about. This height is the one which we have to find out. This baseline is nothing but A upon 2. The value of A is 8. So A upon 2 is 4. So I have 7.5 square being equal to 4 square plus h square. Right? Being equal to 4 square plus h square. So 7.5 square comes out to be 5625 or 56.25 plus or like minus 16 being equal to h square. So this gives me 40.25 being equal to h square. So when I have 40.25, I would convert it into 4025 upon 100. 25 forza and 25 forza 100 and 25 ones I have another 15 here, 152, 25 sixes and 25 ones. So I would get 161 upon 4. So this is basically my height, and I don't believe that any of the options would match up to this. This, when goes in root, gives me my perfect answer. Okay, this gives me my perfect answer. Is there a possibility of there being something? No. Doesn't seem like that. No. So this is my final answer. Right? So let's move forward. Yeah. So here we are going to talk about the volume formula. The volume formula is base area into 1 by 3 multiplied by height. And the slant edge formula is going to be slant edge square is equal to height square plus a by root 2 whole square. Okay. So here the volume has been asked. The base of a right pyramid is a square of side 8 root 2. If the square is of side 8 root 2, then the base area is going to be 64 into 2. 64 into 2 is 128. 128 centimeter square, and each of its slant edges 10 centimeters. If I have a slant edge, let me use a better color here. If I have this slant edge as 10 centimeters and I would let this go down like this, I would let it go down like this. So I have 10 here, and the base is 8 root 2. The base is 8 root 2, that is the side. I need to find out a upon root 2, which would be equal to 8, and this I can employ in the formula. The formula now talks about 10 square being equal to um, 8 square plus h square, right? I need the height to be in my favor. I need to find out the height first. So 10 square plus 8 square, 10 square is equal to 8 square plus h square. From this, I can deduce that the value of h square is equal to 6 square, because this is again a Pythagorean triplet. So the value of h comes out to be 6 in this case. Once I have the height and once I have the area of the base, what do I need to do? I simply need to employ the formula 1 by 3 into area of the base into height, which is equal to 1 by 3 into 128 into 6, which is nothing but 256 centimeter cube. So 256 centimeter cube is something which we are looking at, right? Let's move forward. The total surface area of a square base of a right pyramid is 1536 meter cube, out of which 37.5% is the area of the base. What is the volume? Again, to find out the volume of a pyramid, we need to employ the formula of 1 by 3 into base area into height. 1 by 3 into base area into height. So, sorry. So what are we actually looking at now? We have the total surface area available, out of which 37.5 is the base area. So out of 1536, if this situation is split into 8 parts, 3 parts are the area of the base, and 5 parts is the lateral surface area or LSA. So this is what I have achieved out of it by saying that 37.5% is the area of the base and LSA is only 5 out of 8. Okay, that is what, 62.5? That is 62.5. So out of the total surface area, let me first find out the area of the base, from which I would be able to calculate the side, or from which out of I would have the area of the base. So let me figure this out first. I have the area of the base as 3 by 8 of 1536. I have 8 ones are, again 8 ones are, this is 72, 8 6 are 7, no, 8 9s are 72. I have 1 9, 8 9s are 72 and 8 2s are 16. Now this being multiplied by 3, 3 2s are 6, 3 9s are 27 and 3 1s are 3. This is 576. So 576 centimeter square is the area of the base that we are looking at, right? 576 is the area of the base that we're looking at. And if the area of the base and the base is a square, then the value of a square is equal to 576. That means one of the sides is equal to a, which is equal to 24. So I have my area, my base or the side of the base as 24. Now what is the volume? What is the volume that we're looking at? So if the base is available as 24, I need to find out the volume now. For the volume, I need to have the base area, I need to have the height. Now height is the tricky portion which you need to find out. I could get 576 as the base area. If I wish to find out the LSA now, I can say that 5 by 8 into 1536 would be the LSA, but that LSA would be of 4 faces, because a square has 4 sides and each of the square would have a face coming up, a triangular face coming up. So 5 by 8 multiplied by 1536 whole divided by 4. This would give you the face or the area of the face of one of the faces. If you have area of one of the faces available, this is what you can do. This is 8 1s are 8, 8 9s are 72, 8 2s are 16. I again have 4, this is 4 4s are 16 and 4 8s are 32. 5 into 48 gives me 120. No, this is not 120, this is 240. Okay, so 240 centimeter square is the area of one of the triangles, right? I'll draw a triangle over here now. This is one of the triangle. the base side is A, which is equal to 24, and I have the area available with me. I'll now try to find out the height of the triangle. The height of this triangle that we are talking about is nothing but the slant edge, sorry, the slant height. So half into slant height multiplied by the base, which is 24, is equal to 240. 24 gets cancelled out as 10 here, and the value of slant height comes out to be 20 centimeters. So I have 20 centimeters as my slant height. If I have slant height and I have the main height that is falling in the center or in the core of the pyramid, then I need to have this baseline. I need to find out this height. 20 is my slant height, and the baseline is half of 24, which is nothing but 12. Using Pythagoras theorem, I can say that the value of h is equal to 20 square minus 12 square. This comes out to be 16. Okay, I'm doing it a little quickly because I really wanted to understand the concept. So I now get the height with me. Now, after using this 1 by 3 into the base area was 576 multiplied by the height, which is equal to 16. Okay, so 3 ones are 3, 3 ones are 3, 3 nines are 27, and 3 twos are 6. Now 16 into 192, 16 twos are 32, 16 nines are 144, 144 plus 3 is 7, 147. So 14, 16 ones is 16 plus 14 is 3072. So 3072 centimeter cube is the value that I'm looking at. I would want all of you to redo this question, redo it yourself, because all the concepts of volumes, all the concepts of pyramids have been taught in just one question. Okay, so please pause the video, try to do it yourself, and then go back to it as well. Right? Let's move to the next question. Now, comparing multiple solids, the volume of the sphere I've already done, cylinder done, cube done, cuboid done. Percentage wastage is something which we think of doing. Unused volume upon original volume. This is nothing new that you're going to learn. Okay, we'll now have multiple different solids which we are going to compare and try to find out what is going on. Okay, we are just left with 3 questions. The radius of a sphere and that of a base of a cylinder are equal. The ratio of the radius of the base of the cylinder to the height of the cylinder is 3:4. What is the ratio of the volume of the sphere to that of the cylinder? Okay, the radius of a sphere is equal to the radius of the cylinder. The ratio of the base of the cylinder to the height of the cylinder. That means the ratio of the cylinder to the height of the cylinder is 3/4. What is the ratio of the volume of the sphere to that of the cylinder? If we simply talk about the volume of the sphere, that comes out to be 4/3 pi rs cube. This is the volume of the sphere. Now talking about volume of the cylinder, this is going to be pi rc square hc, which is going to be equal to pi rc square is nothing but 9 and hc is nothing but 4. So this is pi into 9 into 4, which is equal to 36 pi in our case, right? If I assume that both of them, rs is equal to rc is equal to x, I can say that this is equal to 3x and this is equal to 4x, because we are still talking about ratio. So we have 36 pi x cube here as the volume of the cylinder, and 4/3 pi rs cube. Rs doesn't have any of its own existence anymore, right? Rs doesn't have any of its own existence anymore. Then so I can say that this is nothing but 4/3 pi x cube, and I need to find out the ratio between this and 36 pi x cube. The x cube and the x cubes gets cancelled. The pi and the pi go away. And this is 4 and this is 9. So my answer comes out to be 1:27. Okay, so this was another very interesting question. Try to learn it by redoing the question on your own. So we were talking about the wastage, and wastage is basically unused volume upon original volume. So a cone of height 42 centimeters and base diameter 42 centimeters is cut from a wooden sphere of radius 24 centimeters. Find the percentage of wood wasted. So what is the percentage, or what is the volume of the wood utilized? The thing which is cut off is something which is utilized, which is cut out of something. So the height is 42, the height is 42 and the radius is 21, because 42 upon 2 is 21. So a cone, the volume of a cone is 1 by 3 pi r cube. I would not be using pi right away. 1 by 3 pi r square h. So pi into r square is 21 square into h is 42, right? So this is the used volume. What about a wooden sphere of radius 24? 4 by 3 pi 24 cube. This is the total one. If I find out the ratio of used upon total, and in the end I subtract the used out of the total, then I would get the percentage or the fraction of the unused or the wasted. Let me help you in this way. If I'm putting the used thing in the into perspective, so pi by 3 cancels out 42 by 14, so 14 into 21 into 21. If I talk about the total, this is the used side. There is a ratio which I am trying to find out between the used and the total. The total which I have is 4 by 3 pi r cube, 4 into pi into 24 into 24, and 24 upon 3 is nothing but 8. So this is it. There is no square left right now. So I'll quickly cancel things out, and this is equal to total. I would use a different color pen for cancelling things out. The pi goes with the pi. 3 7s are 21, 3 8s are 24, 3 7s are 21, 3 8s are 24. 2 2s are 4, 2 7s are 14. What I am left with here is 7 cube upon 2 into 8 cube, which ultimately comes out to be 7 cube is 343. No, 289 into, yeah, it's 343. 343 whole upon 8 cube is 512. 512 into 2 is 1024. So this is the percentage of wood used, and this is the numerical value of the wood used, and this is the numerical value of the total wood available. If I subtract out of 1024 343, that is when I would achieve 9, and this is 6. So 681 would be the wasted wood. 681 would be the wasted wood. So 681 upon total, which is 1024, would give me the percentage of wood wasted. So this is basically my final answer. So this would come out to be somewhere around 68%, a little less than 68%. So roughly around 65% is my answer. Okay, I hope everybody is satisfied with this sort of a response, right? 65 or maybe 64%. So 64% of the wood got wasted in this process. Good enough? Let's move on. Now, this is the last and the final question. A cone and a cylinder have the same height, and the radius of the cone is twice that of the cylinder. So we are comparing a cone and we are comparing a cylinder. Okay, we have a cone at one side, we have a cylinder at one side. We are talking about the radius, we are talking about the height. we'll be writing down the ratios here. The cone and the cylinder have the same height, so the height is going to be 1 is to 1 in ratio, and the radius of the cone is twice that of the cylinder, so 2 is to 1. This is the situation we are looking at. What is the ratio of the volumes? Ratio of the volumes, the formula is 1 by 3 pi r square h. This is h with the ratio pi r square h. So this is 1 by 3 multiplied by pi multiplied by 8 into 1. This is pi into 1 into 1. The pi and the pi get cancelled. The pi and the pi get cancelled. This is not 8. This is basically 4. This is 4. Why? Because r square is 2. So r is 2 and r square would be 4. Okay. So 4 is to 1. So from here I can deduce that 4 by 3 is to 1 is my answer, or more simply 4 is to 3 is my final answer. So this is the ratio between the volume of the cone to that of the cylinder when the radiuses are in the ratio of 2 is to 1 and the heights are equal. Okay, so I hope you've understood the entire chapter thoroughly. If not, please pause at the relevant places, try to figure out where you couldn't understand. You may write in the comments what you didn't understand and we would promptly reply back. Till then, thank you.